Many Worlds Interpretation. The Many Worlds Interpretation, or MWI, is a fascinating way to think about the universe and how it behaves on the smallest scales. It suggests that every time an event happens, no matter how small, the universe splits into multiple versions of itself. Each version shows a different outcome of the event. These versions, or worlds, exist at the same time but don't interact with each other. This idea comes from quantum mechanics, the branch of science that deals with the behavior of very tiny things like atoms and particles. In quantum mechanics, particles don't have fixed positions or states. Instead, they can exist in several states at the same time. This is called superposition. For example, a particle could spin both clockwise and counterclockwise at the same time. But when we observe the particle, we see it in only one state. Scientists used to explain this by saying the act of observing caused the particle to choose one state, a process called wave function collapse. MWI challenges this explanation. Instead of the particle collapsing into one state, MWI says that the universe itself splits. Each possible outcome of the particle's state happens in its own version of the universe. If the particle can spin both clockwise and counterclockwise, one universe forms where it spins clockwise, and another forms where it spins counterclockwise. Both are real, but they belong to separate realities. Let's use a coin flip as an example. If you flip a coin, it can land on heads or tails. In your everyday experience, the coin lands one way, and that's the result you see. But according to MWI, the universe splits when the coin flips. In one universe, the coin lands on heads. In another, it lands on tails. Both outcomes are real, but you can only experience one of them. The other outcome happens in a universe you can't see. If MWI is correct, there could be countless versions of you living in other universes. Every choice you make creates a new branch of reality. For example, in one universe, you might decide to skip breakfast. In another, you eat cereal. In yet another, you choose pancakes. It's not just your choices that create these branches. Every single event, even tiny ones involving particles, creates splits in the universe. That means the number of universes could be unimaginably large. MWI is one way to explain the strange behavior of particles in quantum mechanics. Without it, scientists rely on the idea of wave function collapse, which has always been hard to define clearly. MWI avoids the problem by saying that all possible outcomes happen, just in separate realities. This makes the math of quantum mechanics work without needing extra rules. Another interesting idea from MWI is that there's no randomness in the universe. In our everyday experience, quantum events, like where a particle might appear, seem random. But if every possible outcome happens in its own universe, nothing is truly random. Every possibility exists somewhere. One challenge with MWI is that it's hard to test. The other universes it describes don't interact with ours, so we can't see or measure them. This makes it an interpretation rather than a testable theory. Still, many scientists like it because it explains quantum mechanics without adding mysterious concepts like wave function collapse. MWI has interesting implications for how we think about ourselves and the universe. If it's true, then every decision you've ever made, and every decision you didn't make, exists in some version of reality. There's a universe where you chose a completely different career, met different people, or lived in a different place. These versions of you are living their own lives, unaware of your existence, just as you are unaware of theirs. The Many Worlds interpretation might sound like something from a science fiction story, but it's based on real science. Physicist Hugh Everett first proposed the idea in 1957. Since then, it has gained support from many scientists who study quantum mechanics. However, not everyone agrees with it, and there are other ways to interpret quantum mechanics. MWI doesn't solve every mystery of the universe, but it gives us a way to think about the strange behavior of particles and events. Whether or not it's true, it challenges us to imagine a reality far more complex and far more connected than we ever thought possible. The next time you make a decision or see something happen, remember, somewhere in the vast multiverse, another version of you is living a completely different life. Whether you're flipping a coin, choosing a path, or just watching the world go by, every possibility is out there, waiting in its own universe. Bubble universes. The bubble universe idea comes from a theory called eternal inflation. which explains how our universe might have started and what might lie beyond it. According to this idea, our universe isn't the only one. Instead, it's one bubble in a vast foam of universes, each existing separately, like bubbles in a sink full of soap suds. To understand bubble universes, we first need to understand inflation. Scientists believe that, just after the Big Bang, the universe expanded extremely fast for a very short period. This process is called inflation. After inflation slowed down, our universe began to grow at a slower rate, forming stars, galaxies, and everything we see today. But eternal inflation suggests that this process didn't stop everywhere. Some regions of space kept expanding rapidly, creating new bubbles. Each bubble becomes its own universe, with its own set of physical laws and properties. Our universe is just one of these bubbles. Each bubble universe can be completely different from ours. Some might have the same laws of physics, but others might have different rules. For example, the strength of gravity might be weaker or stronger. Light might travel at a different speed. Entirely different particles or forces might exist. In some bubbles, life might be impossible because the conditions are too harsh or too strange. In others, life might thrive, but in ways we can't imagine. Between these bubbles is a space that's constantly expanding. This space is often called the inflationary field. It's like the space between soap bubbles in a foam. The bubbles don't interact because the inflationary field keeps pushing them apart. This means that even though there may be countless other universes, we can't travel to or communicate with them. Our universe likely formed when a tiny part of the inflationary field slowed down and stabilized, creating a bubble. Inside this bubble, the conditions were just right for particles, atoms, and eventually stars and planets to form. This slowing down is what allowed our universe to grow and evolve into what we see today. We don't have direct evidence for bubble universes because they exist far beyond what we can observe. However, some clues might hint at their existence. The cosmic microwave background, CMB. The CMB is faint radiation left over from the Big Bang. Some scientists believe unusual patterns in the CMB might be caused by our bubble interacting with another bubble in the distant past. Fine-tuning of the universe. Our universe's laws and constants seem perfectly tuned for life. Bubble universe theory offers an explanation. If there are countless universes, some will have the right conditions for life by chance. The bubble universe idea suggests that our universe is just one part of a much larger reality. It changes how we think about our place in the cosmos. Instead of being the only universe, we might be one of countless others. Each bubble represents a different version of existence, with its own unique story. This idea also raises questions about whether anything connects these bubbles. Could there be a way to travel between them? Could they influence each other? For now, these questions remain unanswered. Bubble universes offer a way to understand why our universe is the way it is. Instead of searching for one ultimate explanation for everything, this theory suggests that our universe is just one possibility. The physical laws and constants we observe are not universal. They're just specific to our bubble. Proving the existence of bubble universes is difficult because we can only observe what's inside our own bubble. The edge of our universe, known as the observable horizon, is the farthest point we can see. Anything beyond that is hidden from us. However, scientists continue to study clues like the cosmic microwave background and develop theories that might one day provide evidence. If bubble universes exist, they change how we see ourselves and our universe. Instead of being the center of everything, we are part of a much larger, more complex reality. Each bubble is like a storybook, with its own characters, settings, and rules. Our story is just one among countless others. The next time you see bubbles floating in the air or forming in water, think of the bubble universe idea. Somewhere out there, beyond what we can see, other bubbles might exist, each holding a universe with its own unique version of reality. Our universe is just one bubble in a cosmic sea. The quantum multiverse is an idea that comes from quantum mechanics, the science that studies how very tiny things like atoms and particles behave. It suggests that there isn't just one universe, but many. These universes exist side by side, forming what we call a multiverse. To understand this, we need to look at how particles behave in the quantum world. Unlike larger objects, particles can be in multiple states at the same time. This is called superposition. For example, an electron can be in two places at once, or it can spin in two directions at the same time. When we observe it, however, it appears to choose one state. The quantum multiverse explains this by saying that every possible outcome happens, but in separate universes. When we observe a particle, the universe splits. In one universe, the particle is in one state. In another universe, it's in a different state. These universes don't interact with each other, but they all exist as part of the multiverse. This idea is often explained with a famous thought experiment called Schrödinger's cat. Imagine a cat in a box with a device that can release poison. The device is controlled by a particle. If the particle is in one state, the poison is released and the cat dies. If the particle is in another state, the poison isn't released and the cat lives. Before you open the box to look, the particle is in superposition. It's in both states at once. That means in a way the cat is both alive and dead at the same time. But when you open the box, you only see one outcome. The cat is either alive or dead. The quantum multiverse suggests that both outcomes happen. When you open the box, the universe splits. In one universe, the cat is alive. In another, it's dead. Both universes are real, but you can only experience one. The quantum multiverse changes how we think about reality. It suggests that every possibility, no matter how unlikely, happens somewhere in the multiverse. If you roll a die, all 6 numbers come up, but each in its own universe. If you make a decision, every choice you could have made creates its own branch of reality. This means the multiverse is incredibly large, with countless versions of events happening all the time. There could be a universe where you became a scientist, another where you live in a different country, and another where dinosaurs never went extinct. This idea comes from the math of quantum mechanics. Scientists use something called the wave function to describe a particle's possible states. The wave function shows all the different states the particle can take. When we observe the particle, it seems to collapse into one state. But the quantum multiverse suggests the wave function doesn't collapse. Instead, the universe branches out and each possible state becomes real in its own separate universe. The quantum multiverse is a serious idea in physics, but it's hard to prove. The other universes it describes don't interact with ours, so we can't observe or measure them. This makes it more of an interpretation of quantum mechanics than a testable theory. Some scientists prefer other interpretations, like the Copenhagen interpretation, which says the wave function does collapse when observed. Despite this, the quantum multiverse is popular because it explains quantum mechanics without adding new rules or assumptions. It also helps make sense of why quantum events seem random. In the multiverse, every possible outcome happens, so nothing is truly random. If the quantum multiverse is real, then every version of you exists somewhere. For example, in one universe, you might have chosen a different career. In another, you might have met different people or made different decisions. In yet another, you might not even exist because your ancestors made different choices. These other versions of you live in their own universes, completely separate from the one you know. You'll never meet them or interact with their worlds, but they are as real as your own. The quantum multiverse changes how we think about the universe and our place in it. It suggests that reality is much bigger and more complex than we can see or experience. It also challenges the idea that our choices and experiences are unique. Every possibility exists somewhere, even if we can't see it. This idea doesn't just apply to small particles. It applies to everything in the universe. The multiverse could contain every possible version of reality, from the smallest particle to the largest galaxy. The quantum multiverse reminds us that the universe is full of possibilities. Every time something happens, the multiverse grows, creating new branches of reality. Somewhere out there, in another universe, every version of your life exists, waiting to be imagined. Simulated universes. The idea of simulated universes is simple. What we experience as reality might not be real at all. Instead, it could be a simulation, much like a highly advanced computer program. Everything we see, hear, and touch, our entire world, could be artificial, created by beings or systems far beyond our understanding. This concept raises big questions about what it means to exist and whether we can trust our senses. The idea of simulated universes comes from the simulation hypothesis. It suggests that a highly advanced civilization, capable of building extremely powerful computers, could simulate entire worlds. These worlds wouldn't just look real, they would feel real to the beings living inside them. If this is possible, there could be many simulated universes, and we might be living in one of them. Imagine playing a video game. In a game, there are characters, landscapes, and rules that control how things work. To the characters in the game, their world seems complete and real, even though it's just lines of code. Now imagine that the game is so advanced that the characters become self-aware. They start to think, feel, and wonder about their existence. That's one way to think about simulated universes. We might be like those characters, living in a world designed by someone else. There are many reasons why an advanced civilization might build simulations. Here are a few possibilities. Scientific research. They might want to study how civilizations develop over time or explore different versions of history. Entertainment. Simulated worlds could be created for fun, like incredibly advanced video games. Preservation. They might want to preserve their own history by creating simulations of their past. Testing new ideas. Simulations could help them test different scenarios, such as new technologies or ways to organize society. If any of these reasons make sense, it's possible that simulations are very common in advanced civilizations. And if they're common, the chances that we are living in a base reality, the original, non-simulated universe, might be very small. If we live in a simulated universe, would there be any way to know? This is a tricky question, but some scientists and philosophers have suggested a few clues we might look for. Unusual patterns in physics. If the rules of our universe are based on a simulation, they might not be perfect. We might find glitches or limits, like tiny inconsistencies in how particles behave. Digital signatures. Some researchers think we might find evidence of a grid or structure in the universe, similar to how pixels make up a digital image. Complexity limits. A simulation would have limits, no matter how advanced it is. For example, the number of particles or events it can handle at once might be capped. So far, we haven't found any clear evidence that our universe is a simulation. However, the idea remains hard to disprove. If the simulation is well designed, it might be impossible to detect from the inside. The idea of simulated universes might sound like science fiction, but many serious thinkers consider it possible. Philosopher Nick Bostrom famously argued that at least one of three things must be true. No civilization ever becomes advanced enough to create simulations. Advanced civilizations can create simulations, but they choose not to. We are almost certainly living in a simulation. This argument doesn't prove we live in a simulation, but it makes the idea hard to dismiss. Even scientists like Neil deGrasse Tyson and Elon Musk have said the odds of living in base reality might be very low. If we live in a simulated universe, it changes how we think about existence. For one, it suggests that our reality has a creator, though not necessarily in the religious sense. This creator could be a person, an advanced computer, or something we can't even imagine. It also raises questions about free will. Are our thoughts and actions truly our own, or are they part of the simulation's programming? If we're in a simulation, does it mean our choices matter less, or does it make them even more special because someone designed this world for us? Finally, it changes how we think about the universe's end. If the simulation were turned off, everything we know would disappear. This is different from the natural processes that scientists believe will eventually end the universe, like heat death or a big crunch. For most of us, the idea of a simulated universe doesn't change much about our daily lives. Whether or not our reality is real, we still experience it in the same way. We still have relationships, make decisions, and find meaning in the things we do. In fact, thinking about simulated universes can inspire us to explore deeper questions about existence, consciousness, and what it means to be alive. If nothing else, it's a reminder that the universe is full of mysteries we may never fully understand. The idea of simulated universes is both exciting and unsettling. It challenges what we think we know about reality and forces us to consider possibilities that go beyond our everyday experience. Whether or not we live in a simulation, the fact that we can even ask this question shows the depth of human curiosity and our endless desire to understand the world, no matter how real or unreal it might be. Holographic Universe. The holographic universe idea suggests that our entire universe might be like a hologram. This doesn't mean it's fake or imaginary. Instead, it means everything we experience in 3 dimensions, space, time, and matter, might be a projection of information stored on a 2-dimensional surface. To understand this, think about a hologram. A hologram is a flat, 2D image that looks 3-dimensional when light hits it in a certain way. The holographic universe theory works similarly. It suggests that everything we see and feel as real could come from information encoded on a distant, flat surface, much like a hologram projecting into space. The holographic universe theory comes from physics, specifically studies of black holes. Scientists discovered something strange about black holes. When objects fall into one, the amount of information the black hole can hold doesn't depend on the object's volume. Instead, it depends on the surface area of the black hole's event horizon, the boundary around it. This finding led scientists to ask, could the information of our entire universe also be stored on a surface, rather than spread out through the universe itself? In this view, the universe we live in is like a 3D projection of this 2D information. The idea is tied to quantum mechanics and general relativity, 2 fundamental theories of physics. These theories don't always agree with each other, but the holographic principle could be a way to bring them together. If the universe works like a hologram, then everything we see, from galaxies to atoms, emerges from information stored on a faraway surface. This surface might be located at the edges of the universe, but we can't see or touch it directly. Instead, we experience its effects as our 3D reality. The holographic universe doesn't mean our world isn't real. You can still touch objects, see the stars, and live your life as normal. What it does mean is that the nature of reality might be different from what we assume. Instead of existing as solid and separate, everything could be interconnected, built from the same underlying information. Think of it like a video game. When you play, everything looks like a real 3D world, but the game is actually made of code, a flat, digital set of instructions that creates the illusion of depth and space. The holographic principle suggests our universe might work in a similar way. If the universe is a hologram, it could help us understand how the laws of physics work. It might explain why quantum mechanics and relativity, 2 theories that usually clash, could fit together in a larger framework. Scientists are still exploring these ideas, but the holographic principle could provide clues about the universe's deepest mysteries, including what happens inside black holes and what the universe was like at the very beginning. The holographic universe theory is still an idea, not a proven fact. However, there are some intriguing hints that support it. For example, black holes. The discovery that black holes store information on their surfaces sparked the idea. Cosmic noise. Some researchers have studied tiny irregularities in space-time that might point to the universe being pixelated, like a hologram. Still, these are early findings, and much more research is needed to confirm or refute the theory. If the holographic universe is real, it might mean that reality isn't just about the objects and events we see around us. Instead, everything could be part of a deeper, hidden structure that we're only beginning to understand. It challenges us to think differently about what real means and reminds us that the universe may hold surprises far beyond our current knowledge. The holographic universe is a bold and exciting idea. Whether or not it's true, it encourages us to keep asking big questions about the nature of existence. Just as a hologram can reveal hidden details when you look closely, the universe itself may have layers of reality waiting to be uncovered. Parallel dimensions. Parallel dimensions are a way to think about worlds that exist alongside ours, but in a way we can't easily see or touch. These dimensions might share the same space as ours, but they're separated by barriers we don't yet understand. They could follow different rules of physics, have different histories, or even look completely unlike anything we can imagine. To understand parallel dimensions, think about a sheet of paper. Now imagine another sheet of paper lying right on top of it. Each sheet represents a dimension, and even though they're close together, the people or objects on one sheet can't interact with the other. In this analogy, the sheets are parallel because they never touch or overlap in a way that allows them to connect. Scientists use this idea to explain certain mysteries in physics. For example, some theories suggest that parallel dimensions might explain why gravity seems so weak compared to other forces. Gravity might leak into these hidden dimensions, making it appear weaker in our world. The concept of parallel dimensions comes from string theory, a branch of physics that tries to explain how everything in the universe is connected. String theory says that all matter and energy come from tiny, vibrating strings of energy. These strings don't just exist in the 3 dimensions we're familiar with: length, width, height. They might vibrate in as many as 10 or 11 dimensions. Most of these extra dimensions would be curled up so tightly that we can't see or experience them. However, some might be large and parallel to ours. If that's true, they could hold entirely separate worlds with their own space, time, and rules. Parallel dimensions are often used in science fiction to explain strange phenomena, but even in real life, we sometimes wonder if they might be responsible for things we can't explain. For example, déjà vu. Some people believe the feeling of already having experienced something might be caused by a brief connection with a parallel dimension. Ghost sightings. Could what we think of as ghosts actually be glimpses of another dimension that overlaps with ours for a moment? While these ideas are fun to think about, there's no scientific proof linking such events to parallel dimensions. There are several serious scientific ideas about how parallel dimensions might work. Brane theory. In this theory, our universe is a 3-dimensional brane floating in a higher dimensional space. Other branes might exist nearby, each with its own universe. Occasionally, branes could collide, creating phenomena like the Big Bang. Multiverse hypothesis. Some scientists suggest that our universe is just one of many in a larger multiverse. These universes might be parallel to ours, each existing in its own separate bubble. Quantum mechanics. In quantum mechanics, particles can exist in many states at once, a phenomenon called superposition. Some interpretations suggest that these states could represent different realities in parallel dimensions. Extra dimensions in string theory. String theory predicts that some dimensions are too small for us to detect, but if larger extra dimensions exist, they could hold entire worlds that we're unable to perceive. One big question is, if parallel dimensions exist, why can't we see or interact with them? The simplest answer is that they're separated from us by barriers that we don't yet know how to cross. These barriers could be physical, like differences in how time or space works, or they could involve forces that we haven't discovered yet. Some theories suggest that the only way to interact with a parallel dimension would be through extreme conditions, like the intense energy around black holes or at the start of the universe during the Big Bang. Parallel dimensions could be almost anything. Some might look like our universe, with stars, planets, and galaxies. Others might be completely alien, with different physical laws. For example, a parallel dimension might have no gravity. Time might flow backward instead of forward. Space might curve in ways we can't imagine. There's even a possibility that parallel dimensions could have their own versions of you, living different lives based on choices you didn't make. Scientists are exploring ways to detect parallel dimensions, but it's not easy. One idea involves high-energy particle experiments, like those done at the Large Hadron Collider. These experiments might create tiny, temporary black holes that could hint at the presence of other dimensions. Another approach involves studying gravity. If gravity does leak into parallel dimensions, we might find evidence by studying how it behaves on very small or very large scales. Parallel dimensions aren't just a fun idea. They could help answer big questions about our universe. For example, why does the universe behave the way it does? Why are the physical constants like the speed of light what they are? Could life exist in places beyond our universe? If parallel dimensions are real, they would completely change how we see reality. They would show us that our universe is just one piece of a much larger puzzle. Parallel dimensions may sound like science fiction, but they're based on serious scientific ideas. While we may not be able to visit or interact with them yet, their existence could explain some of the biggest mysteries in physics. Whether they're hidden just beyond our reach or completely different from anything we know, parallel dimensions remind us that the universe is far more complex than it seems. Somewhere, out there, or right next to you, another reality might be unfolding in ways we can only imagine. Brane Cosmology. Brane cosmology is an idea about how our universe might fit into a larger, more complex reality. It comes from string theory, which tries to explain how the smallest building blocks of the universe work. Brane cosmology suggests that our universe isn't the whole picture. Instead, it might be like a sheet or brane floating in a much bigger space. The word brane comes from membrane. You can think of a brane as a thin, flexible sheet. Branes can exist in many dimensions, but in this idea, our universe is a three-dimensional brane inside a larger space called the bulk. The bulk has more dimensions than we can see or experience. Imagine our universe as a trampoline. Everything we know, stars, planets, you, me, is stuck on the surface of the trampoline. But the trampoline is in a bigger room. That room is the bulk. The objects on the trampoline can't easily leave its surface, just like we can't leave our brain to explore the bulk. The bulk is where brains, including ours, exist. Other brains might be floating in the bulk alongside ours. These other brains could hold entirely different universes, each with its own rules of physics. Some of these universes might be similar to ours, while others might be completely alien. Even though brains are separate, they might interact. If two brains get close, they could bump into each other. Some scientists think this kind of collision could explain the Big Bang, which is how our universe started. Brane cosmology also tries to explain why gravity is weaker than other forces, like electricity or magnetism. According to this idea, gravity might not be stuck to our brain. Instead, it could spread out into the bulk. This would make it feel weaker in our universe because it's being shared across the larger space. Think of it like this. If you pour water onto a flat surface, it forms a small puddle. The water stays concentrated. But if you pour the same water onto a sponge, it spreads out and looks smaller. In Brane cosmology, the bulk is like the sponge, and gravity spreads out into it, making it weaker in our universe. Brane cosmology depends on the idea that the universe has more dimensions than the three we experience: length, width, and height. We're used to thinking of the universe as 3D plus time. But in Brane cosmology, the bulk could have many more dimensions we can't see or feel. These extra dimensions might be curled up so small that we don't notice them. Some scientists think these extra dimensions could explain strange phenomena, like dark matter. Dark matter is an invisible substance that seems to make up most of the universe's mass. If it exists, it could be the result of interactions with something in the bulk or another brane. One of the most interesting ideas in Brane cosmology is that brane collisions might explain the origin of our universe. If two branes collide, the energy released could create a universe. Some scientists believe this is what caused the Big Bang. In this view, the Big Bang wasn't the beginning of everything. Instead, it was just one event in a much larger, ongoing process involving branes in the bulk. Collisions might also create ripples in the bulk, like the ripples you see when you throw a stone into water. These ripples could affect our universe in subtle ways, possibly explaining mysteries about how space and time behave. If Brane cosmology is true, it changes how we think about our place in the universe. It means our universe is just one part of a much bigger system. Other universes might exist on branes floating near ours, but we can't interact with them directly. Still, their presence could affect us in small ways, like through gravity or other forces. Testing Brane cosmology is challenging because we can't see or interact with the bulk or other branes directly. However, scientists look for clues in how gravity works or in the early history of the universe. For example, tiny variations in the cosmic microwave background, the faint glow left over from the Big Bang, might hint at interactions between branes. Experiments involving particle physics, like those at the Large Hadron Collider, might also provide evidence. If scientists discover particles that seem to leak into extra dimensions, it could support the idea of brains and the bulk. Brane Cosmology gives us a way to think about questions we've been asking for centuries. Where did the universe come from? What else is out there? It's an attempt to go beyond the boundaries of what we know and imagine a larger reality that includes our universe and others. Even if we can't prove this idea right now, it helps scientists explore new possibilities. It also reminds us that the universe might be more complex and more fascinating than we can currently understand. Brane Cosmology paints a picture of the universe as one part of a vast, multidimensional structure. Our universe is like a sheet floating in an enormous space, alongside other universes we can't see. If this idea is true, it could help answer some of the biggest mysteries in science and show us that reality is even stranger than we imagined. Time-as-a-Multiverse. The time-as-a-multiverse idea suggests that time doesn't flow like a river, moving from the past to the future. Instead, every moment, past, present, and future, exists at the same time, like pages in a book. Each moment is its own universe, complete and unchanging. We only experience one page at a time because our consciousness moves through these moments in a sequence. This idea comes from a branch of physics called space-time theory. In this view, the universe isn't just three-dimensional, height, width, and depth. Time is the fourth dimension, and it's woven together with the others to form a structure called space-time. Imagine space-time as a loaf of bread. Each slice of the loaf represents a moment in time. All the slices exist together, but you only see one slice at a time. To understand this better, let's think about how time feels in everyday life. It seems like the present is happening now, the past is gone, and the future hasn't happened yet. But according to the time-as-a-multiverse idea, that's just how we experience time. In reality, the past isn't gone, it still exists. The future isn't waiting to happen, it's already there. Every moment exists all at once, like snapshots in an infinite photo album. Our sense of time moving forward might be like flipping through the pages of a book. You can only read one page at a time, but the other pages are still there. If this idea is true, then every version of you, past, present, and future, exists in its own universe. These universes don't change or interact with each other because they're fixed in space-time. The you reading this now exists in one universe. The you eating breakfast this morning exists in another. The you 10 years from now exists in yet another. But here's the interesting part. The future might already be set. If all moments exist at once, then what we call the future is just as real as the present. It's already there, waiting for you to experience it. This challenges how we think about free will. Are your choices shaping the future, or are you just living out what's already written in the book of space-time? Imagine you're watching a movie. You see the story unfold one scene at a time, and it feels like the characters are making decisions in real time. But the entire movie, beginning, middle, and end, already exists on the film reel. The characters aren't changing the story, they're just following the scenes that were filmed. In the same way, the time-as-a-multiverse idea says that your life is like a movie reel. Every moment is already there, but you're only experiencing one frame at a time. If every moment exists at once, it raises the question, can we visit the past or future? Some scientists think it might be possible, at least in theory. If you could step outside your normal flow of time, you could move to a different slice of the space-time loaf. This is what people often imagine when they think of time travel. However, even if time travel is possible, it's not clear if you could change anything. If the past and future are fixed, traveling to another moment might be like visiting a painting in a museum. You can look at it, but you can't alter it. Other multiverse theories, like the many worlds interpretation, focus on different outcomes or realities branching off from one another. Time-as-a-multiverse doesn't involve branching. Instead, it suggests that every moment is a self-contained universe. These universes don't interact, they just exist side by side in the structure of space-time. One mystery of this idea is how consciousness fits in. If every moment exists at once, why do we only experience one moment at a time? And why do we feel like time is moving forward? Some scientists think that our brains create this sense of flow. Our minds might act like a needle on a record, moving along the grooves of time. The record already has all the songs, but we hear them in sequence. This idea can change how we think about life and death. If every moment exists forever, then the moments you cherish never truly disappear. They remain as part of the space-time structure. The same is true for moments of loss or pain. They don't vanish, they just exist in their own universes. It also means that your future already exists. Instead of feeling uncertain about what's ahead, you might think of it as a part of the universe you haven't experienced yet. The time-as-a-multiverse idea comes from how scientists understand space-time, but it's still just a way of interpreting the universe. We don't have proof that all moments exist simultaneously, and it's hard to test. But it's a logical way to think about time if you accept the idea that space-time is a single, unchanging structure. The time-as-a-multiverse idea reminds us that time might not be as simple as it seems. Every moment, from your first steps as a child to the moment you're in now, could exist together in an eternal space-time structure. Whether or not we ever fully understand time, this concept challenges us to see our lives and the universe itself in a new way. Mathematical Universe Hypothesis. The Mathematical Universe Hypothesis, MUH, is the idea that our universe is not just described by math, but is math. In other words, the universe and everything in it, stars, planets, particles, and even you, can be seen as a mathematical structure. This view suggests that mathematics doesn't just explain reality, it is reality. Think about how we use math to describe the world. We can use equations to explain how planets move, how light travels, or how particles behave. The Mathematical Universe Hypothesis goes a step further. It says that the universe exists because it can be represented by mathematical patterns and relationships. These patterns don't just describe the universe, they are the universe. Imagine a triangle. It doesn't matter whether you draw it on paper, carve it into stone, or just imagine it in your mind. The triangle's properties, like its angles adding up to 180 degrees, are true no matter where or how the triangle exists. According to MUH, the entire universe works the same way. It exists because the math behind it is true, independent of any physical form. This idea was proposed by physicist Max Tegmark. He noticed how deeply mathematics is woven into our understanding of the universe. For example, the laws of physics are expressed in mathematical terms, and they work consistently across time and space. Whether you're studying gravity, electricity, or the expansion of the universe, math always seems to be the key. Tegmark argued that if mathematics is so fundamental to our understanding of reality, maybe reality itself is purely mathematical. He suggested that all possible mathematical structures exist, and the universe we experience is just one of them. If the Mathematical Universe Hypothesis is correct, it changes how we think about reality. It suggests that physical objects like rocks and trees are not fundamentally stuff. Instead, they are patterns in a vast mathematical framework. Even things like consciousness or emotions could be explained as complex arrangements within this framework. This view also has implications for other universes. If all mathematical structures exist, then other universes could be based on entirely different mathematics. These universes might have different laws of physics, or they might look completely alien to anything we can imagine. Consider how video games work. A video game world is built from code, mathematics, and algorithms that define the game's rules. Characters in the game, like a pixelated hero, don't exist physically. They exist because the math behind the game allows them to. In a similar way, Mach suggests that our universe is the result of an underlying mathematical structure. Not everyone agrees with the Mathematical Universe Hypothesis. One question is whether mathematics exists on its own, or if it's something humans invent to make sense of the world. Critics argue that math might just be a tool we use, not the foundation of reality. Another challenge is that MUH is hard to test. It's a philosophical idea as much as a scientific one. We can't prove that the universe is purely mathematical, just like we can't prove the opposite. Still, the hypothesis provides a way to think about why the universe works so well with math. If MUH is correct, it suggests that everything in the universe is connected by mathematical relationships. The stars in the sky, the atoms in your body, and even your thoughts could all be seen as parts of the same mathematical system. It also raises big questions, like, why do we experience the universe the way we do if it's just math? Are there other mathematical structures out there, forming other universes? Can we discover deeper mathematical patterns that explain things we don't yet understand? The mathematical universe hypothesis takes an abstract idea, math, and places it at the center of everything. It suggests that math isn't just a language we use to describe the universe, but the actual fabric of reality. Whether or not this is true, it helps us see the universe as something profoundly logical and interconnected. The next time you look at a star or think about the laws of nature, consider this. Those stars, those laws, and even you might not just follow math, you might be math. If this hypothesis is true, then our universe is a living, breathing expression of mathematics, a puzzle waiting for us to solve. Consciousness-Centric Universes. The idea of consciousness-centric universes suggests that consciousness plays a central role in shaping reality. In this view, the universe might exist because conscious beings observe it, or consciousness itself might create universes. It's a big shift from the way we usually think about the world, where physical objects and events exist independently of us. This idea connects to a concept in quantum mechanics. At the smallest levels of reality, particles behave in strange ways. They don't seem to exist in a single state until they are observed. For example, a particle might be in multiple places at once, but the act of observing it forces it to choose one location. This has led some scientists and philosophers to wonder, does the universe depend on consciousness to exist? One interpretation of quantum mechanics suggests that observation isn't just a passive act. Instead, it might actively shape reality. If this is true, consciousness could be more than just something happening in your brain. It could be tied to how the universe works at a fundamental level. Imagine a tree falling in a forest. If no one is there to hear it, does it still make a sound? In the consciousness-centric view, the more important question might be, if no one observes the tree, does it even fall? Or does the tree exist at all? This way of thinking suggests that the universe might not exist in a fully realized form until someone observes it. Another idea within this concept is that consciousness might not just observe the universe, it might create it. Your thoughts, dreams, and even your imagination could generate entire realities. While this might sound far-fetched, it's not completely out of line with certain interpretations of quantum mechanics. Some theories suggest that reality is deeply tied to information, and consciousness might be a way of organizing or generating that information. Think of your dreams. When you dream, your mind creates vivid experiences, complete with people, places, and events. These dream worlds feel real while you're in them. What if the act of thinking or dreaming creates small, temporary universes? These universes might not last long, or they might not have the same rules as the physical world, but they could still exist in some form. In a consciousness-centric universe, the relationship between you and the cosmos could be more personal than we usually imagine. Instead of being a small, unimportant part of a vast, uncaring universe, you might be a key piece of how the universe exists at all. Your consciousness could shape the way you experience reality, and reality itself might depend on the collective awareness of all conscious beings. If consciousness creates or shapes reality, this changes how we think about life and the universe. For one, it challenges the idea that physical matter is the most real thing. Instead, consciousness might be the foundation of everything. This could also mean that our thoughts and perceptions have more power than we realize. It might even explain certain mysteries, like why the universe seems so perfectly suited for life. Scientists often wonder why the laws of physics are just right for creating stars, planets, and living beings. In a consciousness-centric view, the universe might be fine-tuned because consciousness needs it to be. One challenge with consciousness-centric universes is that they are hard to test scientifically. Consciousness itself is still not well understood. We don't know exactly what it is or how it works, let alone how it might interact with the universe. However, some researchers are exploring whether consciousness can influence physical systems, such as through experiments on decision-making and randomness. These studies are in their early stages, but they hint at a deeper connection between mind and matter. The idea of consciousness-centric universes also has connections to philosophy and spirituality. Many ancient traditions suggest that the universe and the mind are linked. For example, some forms of Buddhism teach that reality is shaped by the mind, while certain Hindu philosophies suggest that the self and the universe are one. These ideas, while not scientific, align in interesting ways with the concept of consciousness-centric universes. The idea of consciousness-centric universes invites us to rethink our place in the cosmos. Instead of being passive observers in a pre-existing world, we might be active participants, or even creators of reality. Whether or not this idea is true, it challenges us to explore the deep mystery of consciousness and its role in the universe. Perhaps the act of thinking about this idea is itself shaping the universe in ways we can't yet imagine. Black hole seed universes. The idea of black hole seed universes suggests that black holes might do more than pull in matter and light. They might create entirely new universes. This concept comes from the study of how black holes behave and how our universe itself might have started. A black hole is a region of space where gravity is so strong that nothing, not even light, can escape. Black holes form when massive stars collapse under their own gravity. At the center of a black hole is something called a singularity, a point where gravity becomes infinitely strong and the normal rules of physics break down. The theory of black hole seed universes suggests that when matter falls into a black hole, it doesn't just disappear. Instead, it might be funneled into another universe. The singularity at the center of the black hole could act like the starting point of a new universe, a kind of Big Bang in another reality. To imagine this, think of a black hole as a tunnel. Matter and energy enter the black hole in one universe and exit into another, where they expand and form a completely new cosmos. Each black hole could be the seed of a new universe, filled with its own stars, galaxies, and even life. This idea is linked to general relativity, the theory that describes gravity and space-time. General relativity allows for extreme conditions, like those inside a black hole, to create new regions of space-time. Some scientists believe that the equations describing black holes also describe how a universe might form. In this view, our own universe could have been born from a black hole in another universe. The Big Bang, which started everything we see today, might have been the result of matter and energy spilling out of a black hole in a parent universe. Each new universe could have its own laws of physics. These laws might depend on the conditions of the black hole that created it. For example, a larger black hole might create a universe with different amounts of matter and energy. The way matter behaves inside the black hole might affect the new universe's physical constants, like the strength of gravity or the speed of light. This could explain why our universe has the specific rules it does. It might simply be one of many universes, each with its own unique properties. Black holes are common in our universe. Most galaxies, including our Milky Way, have a supermassive black hole at their center. If each of these black holes creates a new universe, there could be countless universes connected to ours. Our own universe might even be part of an endless chain, with each universe giving rise to others through its black holes. This theory offers a new way to think about the origins of the universe. Instead of a single Big Bang that happened for no apparent reason, it suggests that universes can form naturally from black holes. This creates a kind of cosmic cycle, where universes are constantly being born and potentially creating others. It also raises questions about our place in the cosmos. If black holes can create universes, is it possible that life, or even intelligence, could influence how universes are made? Some scientists have speculated that advanced civilizations could deliberately create black holes to shape the properties of new universes. This idea is speculative, but it shows how the theory of black hole seed universes can stretch our imagination. Testing this theory is difficult because we can't see what happens inside a black hole. However, some scientists look for clues in the way black holes behave and in the structure of our universe. For example, the distribution of matter and energy in our universe might hint at a connection to a parent universe. Studying black holes could reveal more about the extreme conditions that might create new universes. While we may never directly observe another universe, the math behind this idea fits with our understanding of physics, making it an intriguing possibility. The idea of black hole seed universes invites us to see black holes not just as destructive forces, but as creators of new realities. If this theory is true, our universe is part of a much larger cycle of creation, one where black holes are the gateways to endless possibilities. Somewhere, deep inside the black holes we see in our sky, entire new universes might be forming, carrying the seeds of existence into the unknown. The Big Bounce is an idea about how the universe might work over long periods of time. It suggests that our universe didn't start with the Big Bang and end in a final collapse. Instead, the universe goes through endless cycles of expansion and contraction. This means our universe could be part of an infinite loop, where it bounces back after each collapse to create a new universe. The Big Bounce theory begins with the idea that the universe expands and contracts over time. Right now, the universe is expanding. Galaxies are moving away from each other, and space itself is stretching. Scientists believe this expansion started about 13.8 billion years ago with the Big Bang. But what happens if the universe stops expanding? If gravity becomes stronger than the force pushing the universe outward, the universe could start shrinking. Over time, everything would move closer together until it collapses into a single, incredibly dense point. This event is called the Big Crunch. The Big Bounce theory takes it one step further. Instead of the universe ending with the Big Crunch, it suggests that the universe would bounce back. The energy and matter from the collapse could trigger a new Big Bang, starting a fresh cycle of expansion. In this way, the universe recycles itself endlessly. If the Big Bounce is correct, it means the universe has no true beginning or end. Instead of one single Big Bang, there have been many. Each cycle could last billions or trillions of years, creating new universes with different properties and possibilities. Imagine a bouncing ball. Each time it hits the ground, it rises again, starting a new journey. The Big Bounce works in a similar way, but instead of a ball, it's the entire universe. During the crunch, the universe shrinks. Galaxies, stars, and planets would be pulled closer together. Eventually, the intense pressure and heat would destroy all matter, reducing everything to a dense, hot state. This state would resemble what scientists believe existed at the start of our universe. When the bounce occurs, all that energy bursts outward, creating a new universe. The cycle begins again with new stars, galaxies, and potentially new forms of life. Each new universe could look similar to ours, or it might follow entirely different rules of physics. The Big Bounce theory is based on ideas from quantum mechanics and cosmology. Quantum mechanics studies very small particles, while cosmology looks at the entire universe. Some scientists believe the strange behavior of particles at small scales could prevent the universe from collapsing into a single point during the crunch. Instead, quantum effects might cause the bounce. However, proving the Big Bounce is difficult. Scientists can't directly observe what happens before the Big Bang, or what might occur after the universe ends. Most of what we know about the universe comes from studying the expansion we see today, so evidence for the Big Bounce is still limited. The Big Bounce is one of several ideas about the universe's fate. For example, the Big Freeze suggests the universe will keep expanding forever, cooling as galaxies drift apart. The Big Crunch predicts the universe will collapse into itself, but doesn't include a bounce. The Big Rip imagines the universe's expansion speeding up until everything is torn apart. Unlike these theories, the Big Bounce offers a cycle of rebirth. It explains not just how the universe could end, but how it could begin again. If the Big Bounce is true, it changes how we think about time and existence. Instead of a single timeline stretching from the Big Bang to a distant end, time might be circular. Every event, including the formation of galaxies, the rise of life, and the collapse of the universe, could happen over and over in slightly different ways. It also raises big questions about what came before us. Did a version of our universe exist before the last Big Bounce? Were there earlier versions of you or the Earth in previous cycles? Could patterns repeat across bounces, or is each one completely unique? The Big Bounce offers a way to think about the universe as a never-ending story. Instead of focusing on a beginning or an end, it reminds us that change and renewal are constant. Even if our universe eventually collapses, it may not mean the end of everything. Instead, it could be the start of something entirely new. The Big Bounce is a powerful idea that connects the end of one universe to the birth of another. It suggests that destruction isn't final, it's part of a cycle of renewal that has been happening for eternity. If it's true, the universe we see today is just one chapter in an infinite story, one that will continue long after we are gone. String theory multiverse. The string theory multiverse is an idea about how our universe might fit into a bigger picture. It comes from string theory, a branch of physics that tries to explain how everything in the universe works at its deepest level. String theory says that the tiniest building blocks of the universe aren't particles, like electrons or quarks. Instead, they are tiny, vibrating strings of energy. These strings vibrate in different ways to create all the particles and forces we see in the universe. One of the surprising things about string theory is that it needs extra dimensions to work. We're used to thinking about 3 dimensions of space: length, width, height, and one of time. But string theory says there could be 10 or even 11 dimensions. Most of these extra dimensions are curled up so small that we can't see them, but they might hold the key to understanding the multiverse. The string theory multiverse suggests that our universe is just one of many. Each universe could have its own set of physical laws, such as how strong gravity is or how fast light travels. These universes might form from the way extra dimensions are shaped or folded. In string theory, these shapes are called Calabi-Yau manifolds, and there are countless ways they could be arranged. Each arrangement could create a different universe. Imagine a piece of paper folded into different shapes. Each fold creates a new version of the paper with unique properties. In the multiverse, each fold of these extra dimensions could produce a completely different universe, with its own particles, forces, and physical rules. Our universe seems to have just the right conditions for life. The strength of gravity, the charge of an electron, and other constants are all perfectly tuned. In the string theory multiverse, this might not be a coincidence. If there are countless universes, each with different rules, it's not surprising that at least one of them supports life. We live in that universe because we couldn't exist in a universe where the conditions were different. This idea ties into something called the Anthropic principle. It suggests that the universe appears fine-tuned for life because, in universes where it's not, there's no one around to notice. String theory also connects to the idea of cosmic inflation, the rapid expansion of space that happened just after the Big Bang. Inflation could create pockets of space that grow into separate universes, each with its own unique properties. These universes might form in higher dimensional space, where our universe is like a bubble floating alongside countless others. In string theory, our universe could be a brane, short for membrane, floating in a higher dimensional space. Other branes might hold their own universes. Occasionally, branes could collide, possibly creating events like the Big Bang that start a new universe. One challenge with the string theory multiverse is that these other universes might be completely separate from ours. They could exist in dimensions we can't see or interact with. If that's the case, it would be very hard to test or observe them directly. Some scientists hope to find indirect evidence. For example, the Large Hadron Collider, LHC, might detect particles or forces that suggest extra dimensions. Certain patterns in the cosmic microwave background, the faint glow left over from the Big Bang, might hint at collisions between our universe and another. Gravity, which seems weaker than other forces, might leak into higher dimensions, offering clues about other universes. The string theory multiverse offers a way to explain some of the big questions in physics. For example, why does our universe have the physical laws it does? Why do certain constants, like the speed of light, have specific values? How does the universe fit into the larger reality of space and time? By suggesting that there are many universes, each with different rules, the multiverse idea gives a possible answer. Our universe isn't the only one, it's just one of countless variations. If the string theory multiverse is real, it means reality is far bigger and more complex than we can imagine. Our universe, with its billions of galaxies and trillions of stars, might be just a tiny part of a vast, endless landscape of universes. Each universe could have its own history, its own life forms, and its own version of reality. The string theory multiverse is still an idea, not something we can prove. String theory itself is hard to test because it deals with scales much smaller than anything we can observe directly. Some scientists criticize it for being more philosophy than science. Others see it as a promising step toward a theory of everything, a single framework that explains all the forces and particles in the universe. For now, the string theory multiverse remains a fascinating possibility. It pushes us to think beyond what we can see and imagine a reality that is richer and more varied than we ever thought possible. If the string theory multiverse exists, then somewhere out there, in one of the infinite other universes, the world might look entirely different. Stars might burn blue instead of red, gravity might feel stronger, and the rules of physics might not apply the way they do here. In the grand scheme of things, our universe might be just one thread in a cosmic web of endless possibilities. Anthropic Multiverse. The Anthropic Multiverse is a way to think about why our universe is the way it is. It suggests that there are many different universes, each with its own set of physical laws and conditions. Most of these universes wouldn't support life, but ours does. That's why we're here to ask the question, why is the universe so perfectly suited for life? Our universe seems fine-tuned for life. The laws of physics, the strength of gravity, the way atoms form, all of these have to be just right for stars, planets, and living things to exist. If any of these conditions were slightly different, life might not be possible. The Anthropic Multiverse says that this isn't a coincidence. Instead, it's because there are countless other universes, each with different conditions. In most of these universes, the conditions don't allow life to exist. They might have no stars, no planets, or no stable atoms. But in some universes, like ours, the conditions happen to be right for life. We live in one of those universes because it's the only kind we could live in. This idea is based on something called the anthropic principle. The principle says that we can only observe the universe if it has the right conditions for observers to exist. In other words, we shouldn't be surprised that our universe is fine-tuned for life. If it weren't, we wouldn't be here to notice it. Imagine you're in a room filled with balloons. Most of the balloons are popped, but a few are still intact. If you're holding an intact balloon, you wouldn't be surprised. It's the only kind of balloon you could hold. Similarly, we're in a universe that supports life because it's the only kind we could experience. The multiverse idea expands this thinking. It says there isn't just one universe, there are many. Each universe has its own physical constants and rules. In some universes, gravity might be weaker or stronger. In others, atoms might not form at all. These universes are completely separate, and most of them would look nothing like ours. But if there are enough universes, it's likely that at least one of them will have the right conditions for life. That's the universe we find ourselves in. The multiverse explains why the universe feels special without needing to assume that it was designed this way on purpose. Think about a lottery. Millions of tickets might be sold, but only one wins. To the winner, the event might feel incredible or even unlikely, but with so many tickets, it's almost certain that someone will win. In the same way, if there are countless universes, it's not surprising that at least one of them supports life. We're just winners of this cosmic lottery. The Anthropic Multiverse helps answer one of the biggest questions in science. Why does the universe exist in a way that allows us to be here? Without the multiverse, some people argue that the fine-tuning of the universe is too perfect to be random. This has led to debates about whether the universe was designed or created for life. The multiverse offers an alternative explanation. We're in one of the rare universes where the conditions just happen to work. The biggest challenge with the Anthropic Multiverse is that it's hard to prove. We can't see or measure other universes, so the idea remains theoretical. Critics argue that the multiverse might not be the simplest explanation. They also point out that just because something allows life doesn't mean it needs a multiverse to explain it. The Anthropic Multiverse changes how we think about the universe. Instead of seeing it as a unique, one-of-a-kind place, we might see it as one of many. This doesn't make our universe less special, it just puts it in a larger context. We're still part of something remarkable. A universe where atoms, stars, planets, and life all work together in harmony. The Anthropic Multiverse doesn't just answer questions about why the universe exists, it raises new ones. Are there other universes with intelligent life? How different could other universes be? And what does it mean to live in a universe that feels so perfectly balanced? These questions remind us that the universe we know might be just one chapter in an infinite story. Retrocausality Multiverse. The idea of the Retrocausality Multiverse suggests that events in the future can influence events in the past. In this view, time isn't a straight line moving from the past to the future. Instead, it's a loop or a network where causes and effects can flow in both directions. This means that what you do today might not just affect tomorrow, it could also change yesterday. This concept builds on ideas from quantum mechanics. At the smallest scales, particles don't always behave in ways that match our usual sense of time. For example, when scientists try to measure particles, the act of measurement seems to influence what the particles were doing before they were measured. This strange behavior has led some to wonder if the future might sometimes talk back to the past. To understand retrocausality, imagine this. You're sending an email to yourself 10 years ago. It sounds impossible, but in the retrocausality multiverse, it might happen, not as an email, but as a subtle change in events. Actions in the future could ripple backward in time, creating slight shifts in the past. These shifts might not rewrite history in dramatic ways, but they could shape the path leading to the future. For example, imagine you're trying to solve a problem, like finding a lost set of keys. In the retrocausality multiverse, the version of you who finds the keys tomorrow might send a signal back in time. This signal could give you a hint today, like suddenly remembering where to look. This feedback between future and past could create loops of cause and effect that don't have a clear beginning or end. Instead, they feed into each other in a way that's hard to untangle. In a retrocausality multiverse, every action in the future could create new branches of reality in the past. This means that the universe doesn't just split forward in time, it splits backward too. Imagine a tree where the branches grow not only outward, but also back toward the roots. For example, suppose you make a decision tomorrow that creates a major change in your life. In the retrocausality multiverse, this decision might cause an earlier version of the universe to split into new branches, creating alternate pasts that align with your future choice. These branching realities mean that the multiverse could be even more complex than we imagine. It wouldn't just contain every possible future, it would also contain every possible version of the past, shaped by what happens down the line. Retrocausality challenges how we think about time. In our everyday experience, time moves in one direction. The past causes the present, and the present causes the future. But retrocausality says this isn't the whole story. It suggests that the future might also shape the past, creating a two-way flow of influence. If this is true, it could have big implications for how we understand everything from free will to the structure of the universe. For example, free will. If the future can influence the past, does that mean our choices aren't entirely our own? Or does it mean that we're constantly shaping our own timeline, both forward and backward? Causality. Retrocausality blurs the line between causes and effects. It suggests that the two might be connected in ways we don't yet fully understand. Retrocausality is a fascinating idea, but it's also hard to test. Scientists have explored it through experiments in quantum mechanics, like the famous delayed choice experiment. In these experiments, the way scientists choose to measure a particle seems to change what the particle was doing before the measurement happened. This might hint at retrocausal effects, but it's still a matter of debate. Testing retrocausality on a larger scale is even trickier. Since the effects would involve changes to the past, they might be subtle or hard to notice. For now, retrocausality remains a theoretical idea that challenges how we think about time and reality. The retrocausality multiverse invites us to think about time as more than just a straight line. It suggests that past, present, and future are all connected, forming a web where influences can flow in both directions. If this idea is correct, then the decisions you make tomorrow might not just shape your future, they could also rewrite the story of how you got there. This doesn't mean you'll wake up with a completely different memory of the past. Instead, it means that time might be more flexible than it seems. The past, like the future, could be full of possibilities, constantly influenced by the choices and events that lie ahead. The Retrocausality Multiverse shows us that time might not work the way we think it does. If the future can shape the past, then every moment is part of a larger, interconnected story. You're not just moving forward in time, you're part of a timeline that loops, twists, and evolves in ways we're only beginning to understand. Somewhere in the multiverse, your future self might already be helping you write your past. Membrane collision theory. The membrane collision theory is an idea about how our universe began and how other universes might exist. It comes from a field of science called string theory. String theory suggests that everything in the universe is made up of tiny vibrating strings of energy. These strings don't just exist in 3 dimensions, but in more, including ones we can't see. In this theory, our universe is not all there is. Instead, it is like a giant flat sheet, or membrane, often called a brane for short. There could be other branes floating near ours in a higher dimensional space. These branes can move, stretch, and even collide with each other. When they collide, something extraordinary happens. A collision between branes can create a new universe. The Big Bang is the event that started our universe. Scientists have wondered what could have caused such an enormous release of energy. Membrane collision theory offers a possible answer. It suggests that 2 branes collided, and the energy from this collision created everything in our universe: space, time, matter, and energy. Imagine 2 large sheets hanging in the air, drifting closer and closer. When they finally touch, they create a massive shock wave. This is a simple way to picture how the collision of branes might have created our universe. If this theory is correct, our universe isn't the only one. Each time branes collide, they could create a new universe. These universes might have different physical laws and properties. For example, in one universe, gravity might be stronger, while in another, stars might not form at all. This idea fits into a larger concept called the multiverse, which suggests that many universes exist side by side. The space where these branes float is called the bulk. The bulk is a higher dimensional space that we can't see or experience directly. Our entire universe exists on one brane, and other universes could exist on their own branes, separated from us by dimensions we don't understand. Scientists don't know exactly why branes might collide, but they have some ideas. Branes could be moving through the bulk, like waves on the ocean, eventually coming into contact. This movement might be random, or it might follow patterns based on the laws of physics in higher dimensions. Collisions could happen repeatedly over time. If so, universes might be created, destroyed, and recreated in an endless cycle. This concept is sometimes called the cyclic model. In this model, our universe could be just one chapter in a much larger story. One fascinating part of this theory is that it links the Big Bang to events in a higher dimensional space. It suggests that our universe might be just a small part of a much bigger picture. Everything we see and experience could be just one brane in a vast, multi-dimensional landscape. This theory also hints at the possibility of other universes with completely different rules of physics. These universes would be impossible for us to see or visit, but they might be as real as our own. The idea raises questions about whether anything we know is truly unique. Testing the membrane collision theory is challenging because we can't directly observe other branes or the bulk. However, scientists are looking for indirect evidence. For example, they study the cosmic microwave background radiation, which is the faint afterglow of the Big Bang. If our universe was created by a collision, there might be patterns or irregularities in this radiation that point to such an event. Another approach involves particle physics. Experiments using particle accelerators, like the Large Hadron Collider, might reveal clues about extra dimensions or the behavior of energy at extremely small scales. These experiments could help scientists understand whether branes and the bulk are real. The membrane collision theory helps answer some of the biggest questions about the universe. It provides a possible explanation for how the Big Bang happened and why the universe exists at all. It also opens up new possibilities for understanding the nature of reality and the multiverse. This theory challenges us to think beyond what we can see and measure. It suggests that the universe we know might be just one small part of a much larger and more complex reality. Whether or not the theory is true, it pushes the boundaries of human imagination and scientific inquiry. If membrane collision theory is correct, the universe you live in was born from an event in a higher dimensional space. It's possible that even now, new universes are being created as branes collide somewhere in the bulk. The story of reality might be far bigger than we ever imagined, with endless chapters waiting to unfold. Retroactive universe formation. The idea of retroactive universe formation suggests that the universe's past isn't fixed. Instead, the act of observing or interacting with the universe today can shape or determine what happened in the past. It's as if the universe works backward, letting present events influence its own history. This concept comes from quantum mechanics, where particles behave in ways that seem to defy common sense. In the quantum world, particles can exist in multiple states at the same time. Scientists call this a superposition. But when someone observes a particle, it appears to choose a specific state. Retroactive universe formation takes this one step further. It suggests that the universe might not just respond to observation, but also rewrite its own history to match what we see. Imagine you're looking at a light beam. Light is made of particles called photons. If you set up an experiment to check whether these photons behave like particles or waves, your observation determines the result. Retroactive universe formation asks, what if your decision to observe today changes how the photons behaved in the past? It's as if your observation reaches back in time and decides what the photons did before you even looked. This idea connects to something called the delayed choice experiment, proposed by physicist John Wheeler. In this experiment, scientists observe a particle, like a photon, after it has already passed through part of an experiment. Wheeler suggested that the way you observe the particle after the fact determines how it behaved earlier. The particle's past isn't set in stone until you look. Retroactive universe formation takes this concept to a larger scale. Instead of just particles, it suggests the entire universe might work this way. The universe's history could be flexible, changing based on how we interact with it now. In this view, the past isn't something that was written once and for all. It's something that the present helps decide. If this idea is true, it changes how we think about time and causality. We usually believe that the past causes the present, like a row of dominoes falling in order. Retroactive universe formation flips this idea. It says the present could influence the past. Instead of time flowing in one direction, past and present might work together to shape reality. For example, imagine looking at a star in the night sky. The light you see traveled for millions of years to reach your eyes. Retroactive universe formation suggests that your act of looking could shape what happened to that light long before you were born. The star's history becomes connected to your present observation. Experiments in quantum mechanics give hints that something like this could be possible. The delayed choice experiment, quantum entanglement, and other phenomena show that particles don't always behave in ways that match our everyday understanding of cause and effect. However, retroactive universe formation is still a theory. Scientists can't prove it yet, and many questions remain unanswered. One of the challenges is understanding how this works on a larger scale. Quantum mechanics deals with tiny particles like atoms and electrons. It's not clear how, or if, these effects apply to bigger systems like galaxies or the entire universe. Still, the idea invites us to think about the universe in new ways. Retroactive universe formation makes us rethink how we understand time and reality. It challenges the idea that the past is fixed and unchangeable. If the universe can shape its history based on present events, then the relationship between past, present, and future might be more connected than we thought. This idea also raises interesting questions about our role in the universe. If observation can shape the past, then consciousness might play a bigger part in the fabric of reality than we realize. It suggests that the act of observing and understanding the universe isn't passive. It's an active process that could shape the universe itself. Retroactive universe formation is a mind-bending concept that challenges how we think about time and causality. It suggests that the past and present are not separate but intertwined. The idea may be difficult to prove, but it opens up fascinating possibilities for how reality works. The next time you look at the stars or observe something in the world, consider this. Your act of seeing might be part of what makes the universe the way it is, even in the distant past. Cosmic ghost universes. The idea of cosmic ghost universes is one of the more mysterious and imaginative concepts in modern physics. It suggests that our universe may not be the only one. Other universes could exist that briefly formed and then faded away. These universes might leave behind faint traces, ghosts, that could influence or interact with ours. The concept of ghost universes comes from a branch of physics that studies the beginning and evolution of the cosmos. According to some theories, our universe was born in the Big Bang, a sudden explosion of energy that created space and time. But the Big Bang might not have been a unique event. Tiny quantum fluctuations, random brief changes in energy, could create baby universes all the time. Most of these baby universes might collapse or fade away quickly, but their existence could still leave behind subtle effects in the larger multiverse. These universes are called ghost universes because we cannot see or experience them directly. They may exist for such a short time or in such strange forms that they are invisible to us. However, their presence might still be detectable through their influence on our universe. To understand ghost universes, we need to think about the idea of quantum foam. Quantum foam is a way to describe space at the smallest possible scale. At this level, space is not smooth but constantly bubbling with tiny fluctuations. These fluctuations can create temporary pockets of energy that expand into small universes. Most of these universes might never grow large enough to survive. They could collapse back into nothingness almost immediately. However, their brief existence might affect the universe around them. For example, they could leave behind unusual patterns in the cosmic microwave background, CMB, which is the faint glow left over from the Big Bang. They might create tiny distortions in gravity that we can measure using advanced tools like gravitational wave detectors. Ghost universes could look very different from our own. They might have completely different laws of physics. For example, a ghost universe might have no stars or planets, just clouds of energy. Another might be filled with matter but lack gravity, so nothing holds together. Some might expand so quickly or collapse so fast that they never form any recognizable structures. Because these universes exist for such a short time, they might not evolve in the way our universe has. They could appear and disappear in an instant, almost like flickers of light on a screen. Although ghost universes might seem far away and unrelated to us, they could play a role in shaping our reality. Some scientists think their effects could show up in cosmic background radiation. Patterns or irregularities in the radiation left over from the Big Bang could hint at interactions with other universes. Gravitational waves. Ripples in space-time caused by massive events might carry information about ghost universes that once existed nearby. Dark matter. Some theories suggest that dark matter, the invisible material that makes up most of the universe's mass, could be left over from interactions with ghost universes. These effects are subtle, but scientists are developing tools to detect them. If we find evidence of ghost universes, it could change how we understand the cosmos. Cosmic ghost universes challenge the idea that our universe is unique or permanent. They suggest that the universe might be part of a much larger and more dynamic system. If universes can appear and disappear, it raises questions like, what makes our universe stable and long-lasting? Could our universe ever become a ghost universe itself? Are there universes that interact more directly with ours, even in small ways? These questions push the boundaries of physics and cosmology, encouraging scientists to think beyond the visible universe. Proving the existence of ghost universes is difficult because they are, by nature, fleeting and invisible. However, indirect evidence might be possible. Scientists study the cosmic microwave background and gravitational waves for signs of unusual patterns or distortions that could point to interactions with other universes. While no direct evidence has been found yet, the search is ongoing. The idea of cosmic ghost universes fits into the larger theory of the multiverse, which suggests that countless universes exist beyond our own. Some of these universes might be like ours, with stars, planets, and life. Others could be short-lived ghost universes, appearing and vanishing without ever forming complex structures. Thinking about ghost universes can change how we see our own universe. It reminds us that what we experience is just one small part of a much larger and stranger reality. Whether or not we ever find evidence of these ghostly realms, the idea challenges us to imagine a cosmos that is more dynamic and interconnected than we ever thought possible. Cosmic ghost universes are a reminder that the universe, or multiverse, is full of surprises. These fleeting, invisible worlds might not be something we can see, but they could still leave their mark on our reality. As scientists continue to explore the mysteries of space and time, we may discover that even the briefest sparks in the multiverse have a role to play in shaping the story of existence. Nested universes. The idea of nested universes suggests that universes might exist within each other, like Russian nesting dolls. Our universe could be part of a much larger structure, while at the same time, it might contain smaller universes inside it. These nested universes could be linked through black holes, extra dimensions, or other unknown processes. One version of this idea comes from how black holes work. A black hole forms when a massive star collapses, creating a region where gravity is so strong that nothing, not even light, can escape. But some scientists believe that the immense pressure inside a black hole might compress matter so tightly that it forms a new universe. This would mean that every black hole in our universe could contain its own universe, complete with stars, planets, and life. If this is true, our own universe might exist inside a black hole in another, larger universe. From the outside, our universe would look like a small, dense object. From the inside, it feels vast, like what we see when we look at the night sky. Nested universes could also come from higher dimensions. Our universe might be a slice of a larger structure with many dimensions we can't see. Think of it like a loaf of bread. Each slice is a universe, and the loaf contains all of them together. In this model, universes aren't stacked like physical objects, but overlap in ways that only higher dimensional beings could perceive. These layers could interact in subtle ways. For example, what we call dark matter might be the influence of another universe overlapping with ours. We can't see or touch this other universe, but its gravity could affect ours. Some scientists even speculate that nested universes could exist at the smallest scales. The building blocks of matter, like atoms or even subatomic particles, might contain entire universes. These tiny universes would be completely hidden from us because they operate on a scale far smaller than we can observe. At the same time, our universe could be a small part of something unimaginably larger. If you zoomed out far enough, what we think of as our entire universe might look like a speck inside an even greater cosmos. The concept of nested universes helps us think about how space, time, and reality might be structured. It challenges the way we think about scale. In everyday life, small things like cells or atoms are part of larger things, like bodies and planets. Nested universes apply the same idea to the cosmos. Our universe could be part of something bigger, while also containing smaller universes. This concept also connects to the idea of infinite possibilities. If there are universes within universes, the number of possible realities becomes almost unimaginable. Each nested layer could follow different rules or have its own physics. Testing the idea of nested universes is difficult. If our universe exists inside a black hole, we can't escape it to see what's outside. Similarly, if smaller universes exist inside particles, they might be too small to detect. However, some scientists think clues might come from studying black holes, gravitational waves, or the behavior of particles at the quantum level. For now, the idea of nested universes is a way to imagine the unknown. It doesn't have clear proof, but it fits with some theories in physics, like string theory or quantum mechanics. It also inspires new ways to think about the cosmos and our place within it. If nested universes exist, we might be part of an endless chain of worlds with no clear beginning or end. Our universe could be one of many, existing both inside something greater and containing something smaller. Whether or not we ever find evidence for this idea, it opens the door to a richer understanding of reality. The next time you think about the universe, imagine it not as a single, isolated space, but as one piece in an infinite puzzle of worlds. Fractal Multiverse. The fractal multiverse is a way of imagining the universe as part of a repeating pattern. In this view, universes are not isolated or random, but connected in a self-similar structure that repeats on different scales. This idea is inspired by fractals, which are shapes or patterns that look the same no matter how much you zoom in or out. A fractal is a pattern that repeats itself at different levels of magnification. You can find fractals in nature, like the branching of trees, the shapes of snowflakes, or the way rivers split into smaller streams. If you zoom in on part of a fractal, you'll see the same shape repeated over and over, no matter how small the piece. The fractal multiverse takes this idea and applies it to the structure of the cosmos. It suggests that the universe we live in is just one piece of a much larger pattern. When you zoom out, you might see that our universe is part of a bigger universe. Zoom out further, and that larger universe is part of an even larger one. This process could go on forever, creating an infinite, nested structure. In a fractal multiverse, every universe might follow the same rules of structure and behavior, but on different scales. For example, on a small scale, particles in our universe might behave like entire galaxies in another universe. The way stars form and die in our universe could mirror the life cycle of entire universes in a larger structure. The idea doesn't stop there. If you zoom in instead of out, you might find that the particles and forces in our universe are themselves tiny universes with their own galaxies, stars, and planets. Fractals are a powerful way to describe the natural world. Scientists use them to study everything from the shapes of mountains to the way blood flows through the body. Applying this idea to the universe offers a way to think about complex cosmic patterns in a simple, repeating way. The fractal multiverse helps us imagine how the cosmos might look on scales we can't see. It also fits with certain ideas in physics, like how forces and particles seem to follow simple repeating laws. Think of a tree. From a distance, it looks like a single shape, but if you zoom in on a branch, it has the same branching structure as the whole tree. Zoom in further and you see the same pattern in smaller twigs. This is what self-similarity means. In a fractal multiverse, our universe is like one branch of a tree. If you zoom out, you see the whole tree, which is a larger multiverse. Zoom in, and you might find smaller universes within ours, just like smaller branches on the same tree. The fractal multiverse is more of an idea than a proven theory. However, some parts of science hint at fractal patterns in the universe. For example, the way galaxies are arranged in space looks a lot like a fractal. Clusters of galaxies grouped together in patterns that repeat on different scales. Certain models in quantum mechanics and string theory use ideas similar to fractals to describe particles and forces. These clues don't prove that the multiverse is fractal, but they show that nature often follows fractal patterns. If the fractal multiverse is real, it changes how we think about our place in the cosmos. Instead of being just one universe in an endless void, our universe might be part of a repeating, interconnected system. Every part of this system follows the same basic patterns, no matter how big or small. It also suggests that the cosmos might be infinite in both directions. You could zoom out forever and keep finding larger structures. At the same time, you could zoom in forever and keep finding smaller ones. One challenge with the fractal multiverse is that it's hard to test. We can't see beyond the edges of our universe, so we don't know if larger structures exist. Similarly, we don't have tools to zoom in far enough to see if particles contain tiny universes. Without direct evidence, the fractal multiverse remains an idea rather than a proven fact. Another challenge is that fractals in nature eventually stop repeating. A tree's branches don't go on forever, and even the most intricate fractal patterns have limits. Scientists don't know if the universe would follow this rule, or if it could truly be infinite. The fractal multiverse offers a new way to think about reality. It connects the small and the large, showing how they might follow the same rules. It also suggests that the universe might not be random, but part of a larger, ordered system. This idea doesn't answer every question, but it provides a framework for thinking about the universe in a simple and elegant way. Whether or not it's true, it reminds us that the cosmos is vast, interconnected, and full of patterns waiting to be discovered. Imagine standing in front of a mirror, holding another mirror. The reflections seem to go on forever, each one smaller than the last. The fractal multiverse works like this, with universes reflecting and repeating across infinite scales. Whether you look up at the stars or down at the smallest particle, the same patterns might be there, connecting everything in ways we can only begin to understand. The chaotic multiverse is a way to imagine how the cosmos could exist in an endless variety of forms. This idea suggests that universes are created randomly, without any guiding rules or patterns. Each universe is its own separate reality, with unique properties and behaviors. In this view, the multiverse is not a neat system, but a sprawling, unpredictable collection of worlds. In everyday life, chaos means disorder or confusion. In the chaotic multiverse, chaos means that anything can happen. Universes can have different laws of physics, different types of matter, or no matter at all. Some universes might look like ours, with galaxies, stars, and planets. Others might be unrecognizable, with strange dimensions or no time at all. The possibilities are endless because there are no limits. The idea of a chaotic multiverse often comes from theories about how universes might form. One explanation is that new universes are born from something called quantum fluctuations. A quantum fluctuation is a tiny random change that happens in empty space. These changes can cause energy to build up and, under the right conditions, create a universe. Since the process is random, each universe can turn out completely different. Another idea comes from cosmic inflation. This is the theory that our universe expanded rapidly just after the Big Bang. If this inflation happens in other regions of space, it could create separate universes. Each one would start with its own random conditions, leading to its own unique structure. In the chaotic multiverse, the variety of universes is limitless. Some might seem familiar, with stars and planets like ours. Others might be completely alien. For example, a universe might have no gravity, so nothing sticks together. Another might have time that flows backward instead of forward. Some universes could have extra dimensions, making space feel completely different. Because these universes are created randomly, most would not support life as we know it. In some, atoms might not even form, but in a multiverse this vast, even the rarest conditions can exist somewhere. That means there could be universes where intelligent beings live, just like us, or completely unlike us. If the chaotic multiverse is real, it means our universe is just one of many. It doesn't have a special role or design. Instead, it's one example of what's possible in a system with no rules. This might feel unsettling, but it also helps explain why our universe has the conditions it does. Among countless random universes, some will naturally have the right mix of ingredients for stars, planets, and life to form. We happen to live in one of those rare universes. Like other multiverse ideas, the chaotic multiverse is hard to test. If these other universes exist, they are separate from ours and don't leave direct evidence we can measure. However, some theories, like cosmic inflation, provide clues. For example, scientists study patterns in the cosmic microwave background, the faint radiation left over from the Big Bang. These patterns might show hints of interactions between our universe and others. Still, the chaotic multiverse remains an idea, not a proven fact. It's one way to think about how the cosmos might work, but it's not the only explanation. The chaotic multiverse helps us explore questions about existence. Why does our universe have the laws of physics it does? Why does it seem so orderly when chaos could create so many other possibilities? This idea reminds us that what we see might be just one small part of a much larger reality. It also changes how we think about chance. If universes are created randomly, then our existence isn't the result of a plan or a design. Instead, it's one outcome in a cosmic lottery. This doesn't make life any less meaningful. It just means we're part of something bigger and more mysterious than we can fully understand. The chaotic multiverse challenges us to imagine a cosmos without limits. It asks us to consider a reality filled with endless possibilities, where even the most unlikely things can exist somewhere. Whether or not it's true, This idea opens our minds to the sheer scale and variety of the universe. Somewhere out there, or perhaps nowhere at all, every possibility might exist, waiting to be imagined. Consciousness Multiverse. The Consciousness Multiverse is a thought-provoking idea that links the nature of reality to the power of the mind. It suggests that your consciousness, your thoughts, feelings, and awareness might play a direct role in creating or accessing alternate universes. These universes could reflect the infinite possibilities your mind can imagine, and your dreams or thoughts might serve as a doorway to them. This concept starts with the question, what if your mind doesn't just exist in the universe, but actively shapes it? In many ways, your consciousness already creates your personal experience of reality. For example, how you perceive the world depends on your memories, emotions, and focus. But the Consciousness Multiverse goes a step further. It suggests that your mind might not just interpret reality, it might actually create or interact with other realities. At its core, this idea comes from the possibility that consciousness is tied to the quantum world. Quantum mechanics shows us that particles can exist in many states at once, a phenomenon known as superposition. Some scientists and philosophers wonder if consciousness itself could be a kind of observer that helps shape these states into specific realities. In the Consciousness Multiverse, your awareness might branch out into different versions of reality based on your thoughts and choices. For example, if you imagine yourself becoming a musician, a version of reality where this happens might come into existence. If you dream about flying, your dream could represent a momentary connection to a universe where you can. This doesn't mean you can control these universes like magic, but it suggests that the act of thinking or dreaming could link you to other possibilities that already exist. One of the most intriguing parts of this idea is how it relates to dreams. In a dream, you might find yourself in a completely different place or situation, often with no clear explanation. The Consciousness Multiverse suggests that dreams might be more than random brain activity. Instead, they could be glimpses into other universes where the rules of reality are different. For example, in one dream, you might be living in a city you've never visited. Perhaps this city exists in another universe where your life took a different path. In another, you might interact with people you've never met. These could be versions of people from a parallel reality. This idea could explain why dreams sometimes feel so vivid and meaningful, even when they don't seem to match the reality you know. The Consciousness Multiverse also ties closely to the power of imagination. When you imagine something, you create a mental picture of a possibility. Some proponents of this idea believe that imagination might be a way to tune in to alternate realities. For example, when you picture yourself doing something completely new, you might be connecting to a version of you that already exists in another universe. This could mean that every thought, no matter how fleeting, might leave an imprint on reality. If you focus deeply on a possibility, it might strengthen your connection to a universe where that possibility exists. While the Consciousness Multiverse isn't proven, it has intriguing connections to real scientific ideas. Quantum mechanics has shown us that the act of observing can influence the behavior of particles. This raises questions about the role of consciousness in shaping reality. Some scientists have even speculated that the universe itself might be a kind of quantum system influenced by awareness. Another connection comes from neuroscience, which studies how the brain generates thoughts and perceptions. Some theories suggest that consciousness might not be limited to the brain, but could interact with the fabric of reality itself. If the Consciousness Multiverse is real, it changes how we think about the mind and its role in the universe. It suggests that every thought and decision you make could connect to a version of reality where that thought or decision plays out. Your dreams and imagination might be more than random. They could offer glimpses into alternate possibilities. Your awareness might have a profound influence on the nature of reality, even if you don't fully understand how. This idea raises many questions. If consciousness can connect to other universes, why can't we control or visit them at will? Why do we seem to experience only one reality at a time? Are these alternate universes truly separate, or are they just mental constructs created by the brain? Because this idea is so speculative, it's hard to test or prove. Scientists and philosophers continue to debate whether consciousness could have this kind of power, and if so, what it means for our understanding of reality. The Consciousness Multiverse invites us to look at the mind in a new way. It suggests that your thoughts, dreams, and awareness might be more powerful than you realize, connecting you to a web of infinite possibilities. Whether or not this idea turns out to be true, it offers a fascinating perspective on the role of consciousness in the vast mystery of the universe. So the next time you dream, wonder, could it be more than just a dream? Could it be a glimpse into another world shaped by your own mind? The concept of quantum foam comes from the idea that the universe, at its smallest scale, isn't smooth and calm, but chaotic and unpredictable. Imagine the surface of a boiling pot of water, with bubbles forming and popping constantly. This is a good way to picture quantum foam, a seething, ever-changing foundation of reality. Quantum foam describes the very tiny structure of space and time, often referred to as the fabric of the universe. At everyday scales, space and time feel smooth and continuous. We can walk across a room or measure time with a clock, and everything seems predictable. But when we zoom into scales much smaller than atoms, down to what scientists call the Planck scale, space and time become wild and unstable. At this level, space and time seem to behave more like waves than solid objects. Tiny fluctuations create what looks like foam, where particles, energy, and even miniature universes might briefly appear and disappear. This chaotic behavior is a result of quantum mechanics, the branch of science that explains how particles behave at very small scales. In quantum mechanics, uncertainty is built into the system. For example, a particle's exact position and energy can't be measured precisely at the same time. Energy can randomly borrow from nothing, creating brief bursts of activity. Because of this, even empty space isn't truly empty. Instead, it's full of these tiny, random fluctuations. This activity gives rise to quantum foam. One fascinating idea is that the bubbles in quantum foam might be tiny, short-lived universes. These universes would pop into existence for a fraction of a second and then vanish again. Most of them would be too small or unstable to last, but they could provide clues about how larger universes like ours come into being. In fact, some scientists think that our universe might have started as one of these quantum bubbles. If a bubble grew large enough, it could stretch and expand into a full universe, just like the one we live in today. At first glance, quantum foam might seem far removed from everyday life. It happens on scales much smaller than anything we can see or feel, but it plays an important role in how the universe works. For example, quantum foam could explain why particles behave the way they do, including why they appear to pop into existence in experiments. It might also be connected to black holes, dark energy, or other cosmic phenomena that scientists are still trying to understand. If quantum foam is real, it would mean that the universe is far less stable and solid than it appears. The smoothness we experience might only be a result of looking at the universe from a much larger perspective. Quantum foam is incredibly small, so small that it's almost impossible to measure directly. Scientists believe it exists because it fits with what we know about quantum mechanics and how particles behave. Some advanced experiments with particles and lasers might one day give us a closer look, but for now, quantum foam remains a theoretical concept. The idea of quantum foam isn't just about understanding tiny particles. It's also about understanding the foundation of reality itself. If space and time are made of quantum foam, then everything we see, from stars to planets to life itself, is built on a foundation of constant change and unpredictability. This idea also challenges how we think about the universe. Instead of seeing it as a fixed, stable system, we might need to think of it as something much more dynamic, always bubbling, shifting, and evolving. Quantum foam gives us a glimpse into the hidden complexity of the universe. It shows that even the emptiest parts of space are full of activity. It might even hold the key to understanding how universes are born. So the next time you think about empty space, remember, it's not empty at all. It's alive with the constant bubbling of quantum foam, the foundation of everything we know. Time loop universes. The concept of time loop universes is simple yet fascinating. It suggests that some universes might be caught in an endless cycle, repeating the same events over and over again. Instead of time moving forward in a straight line, it circles back on itself, creating a loop. This means that everything that has happened before will happen again in exactly the same way. A time loop is like replaying the same moment or series of events on a loop, much like rewinding and replaying a video. In a universe caught in a time loop, time doesn't stretch infinitely into the past or future. Instead, it has boundaries. When time reaches its end, it starts over from the beginning. Imagine waking up every morning to the same day, with the same events happening in the same order, forever. While this idea might sound like science fiction, it has roots in serious scientific and philosophical discussions. Some physicists wonder if time itself might be cyclical, especially when thinking about the universe as a whole. The idea of a time loop universe is tied to how the universe might behave on a large scale. Here are a few theories that suggest time loops could be possible. The Big Bounce. This theory suggests that instead of the universe ending in a big crunch, where everything collapses back together, it could bounce back and expand again. In this scenario, the universe might reset itself, with the same conditions leading to the same events. Every time the universe bounces, it creates a new cycle, but the events within each cycle could be identical. Closed time-like curves, CTCs. In Einstein's theory of relativity, space and time can bend under certain conditions. A closed time-like curve is a path in space-time that loops back on itself. If a universe contains such a curve, it could allow time to loop endlessly. Quantum reset. At the smallest scales, quantum mechanics describes the universe as uncertain and probabilistic. Some scientists think that quantum processes could reset the universe, effectively creating a loop where everything starts over. Living in a time loop universe would be strange. Everything you experience would eventually repeat. If the loop is small, like a single day, you might notice it, as stories like Groundhog Day have imagined. But if the loop spans billions of years, it's unlikely anyone would realize they are living the same events over and over. In a time loop universe, free will becomes a tricky idea. If every event repeats exactly, are you truly making choices, or are you simply following a script written by the loop itself? This raises big questions about whether life in a time loop could feel meaningful. Proving the existence of time loops is extremely difficult. If a loop repeats perfectly, we would have no memory of previous cycles. Everything would seem new each time. The only way we might detect a loop is if something changed between cycles, like a small inconsistency or anomaly in the universe's behavior. However, such a change would mean the loop isn't perfect, and that raises even more questions. Scientists have looked for clues about whether the universe could be cyclical. For example, they study patterns in the cosmic microwave background, CMB, the faint light left over from the Big Bang. If time were looping, there might be signs of repetition in these patterns. So far, no clear evidence has been found. Time loops challenge how we think about time and reality. We often imagine time as linear, with a clear beginning, middle, and end. Time loops suggest that the universe might not have a true beginning or end. Instead, it could exist in a state of eternal repetition. This idea also ties into ancient philosophies. Many cultures, including Hinduism and Buddhism, describe time as cyclical. They imagine the universe as going through endless cycles of creation, destruction, and rebirth. Modern science might be exploring ideas that align with these ancient views. If we are living in a time loop, we wouldn't know it. Every time the loop resets, we would lose all memory of the previous cycle. From your perspective, life would feel normal. But somewhere in the vast structure of the universe, time might be circling back on itself, pulling you along for the ride. This raises a strange question. Could you ever break free from the loop? In theory, if you became aware of the loop and found a way to change something, you might disrupt the cycle. But that would depend on the rules of the loop itself. Time loop universes stretch our imagination and force us to rethink how time works. They remind us that the universe might not be as straightforward as it seems. Whether or not time loops exist, the idea is a powerful way to explore questions about the nature of reality, free will, and the endless possibilities of the cosmos. And who knows? If time is looping, you might be reading this explanation for the millionth time, and you'd never know. White hole multiverse. The idea of a white hole multiverse comes from thinking about black holes and their mysterious properties. Most people know about black holes as regions of space where gravity is so strong that nothing, not even light, can escape. But what if there's a flip side to black holes? A white hole, in theory, is the opposite of a black hole. Instead of pulling everything in, a white hole pushes everything out. It's like a cosmic fountain, ejecting matter and energy into space. This idea leads to an intriguing possibility. What if white holes don't just eject matter and energy into our universe? What if they create entirely new universes? Each white hole could act as the beginning of a new universe, just like how some scientists think the Big Bang started ours. White holes are hypothetical objects in physics. Unlike black holes, which trap anything that comes near them, white holes are theorized to repel everything. They are like time-reversed black holes. While a black hole's event horizon is a point of no return, a white hole's event horizon is a point of no entry. Nothing can get in. White holes come from the same equations that describe black holes, part of Einstein's theory of general relativity. But while black holes have been observed, white holes remain purely theoretical. No one has seen one, but they are a logical possibility based on the math. The idea of white holes creating universes comes from thinking about how black holes work. When something falls into a black hole, it gets crushed into a tiny point called a singularity. At the singularity, space and time break down, and the laws of physics as we know them no longer apply. Some scientists think this process might not destroy matter completely. Instead, the singularity could act as a bridge to another universe. In this view, a black hole in our universe might connect to a white hole in another universe. Everything that falls into the black hole could get spit out into a new reality, creating a whole new universe with its own space, time, and physical laws. Our universe could even be the result of such a process, born from a white hole in another cosmos. To imagine how this might happen, think of a black hole as a drain. Everything flows into it, but instead of staying there, it gets funneled into another space. On the other side of that space is a white hole, where all the stuff gets expelled into a new universe. This process could create the conditions for a Big Bang, similar to how our universe started. In this model, a black hole in universe A pulls matter in. That matter travels through a singularity, or some kind of bridge. It emerges in universe B through a white hole as the beginning of a new universe. This cycle could happen again and again, with black holes in new universes creating even more universes. It's like a cosmic tree with each black hole as a seed that grows into its own branch. If the white hole multiverse theory is true, it changes how we think about black holes. Instead of being endpoints where matter disappears forever, black holes could be the engines of creation. They might recycle matter and energy from one universe and use it to form another. This would make the multiverse a constantly evolving system, where universes are born, grow, and eventually die, only to give rise to new ones. This idea also raises an interesting possibility about our own origins. If our universe came from a white hole in another cosmos, it means our Big Bang wasn't the absolute beginning. Instead, it was just one chapter in a much larger story. One reason we haven't observed white holes is that they might exist in universes separate from ours. If a black hole leads to a white hole, the white hole could be completely cut off from the universe where the black hole exists. This would make it impossible to detect white holes from our side. Another reason is that white holes might be incredibly short-lived. They could form and collapse so quickly that we never get a chance to see them. Or they might only exist under extreme conditions, like at the very beginning of a universe when space and time are just forming. The white hole multiverse theory is still highly speculative. It's an idea that comes from combining what we know about black holes, general relativity, and the origins of the universe. While the math supports the possibility of white holes, there's no direct evidence for them yet. That said, this idea fits with other multiverse theories. It suggests that universes might be connected through a web of black holes and white holes, each one giving rise to new realities. It's a way to think about the cosmos as a vast, interconnected system. where no matter is ever truly lost, it just moves from one universe to another. The white hole multiverse theory challenges us to think about the universe in a different way. It suggests that black holes, often seen as destructive forces, might also be creators. They might not just end things, they might also begin them. And if every black hole in our universe is creating a new one, the multiverse could be far larger and more dynamic than we ever imagined. Whether or not this idea turns out to be true, it reminds us how much we still have to learn about the universe. It shows that even the strangest ideas can help us explore the mysteries of existence and our place within it. Observer-dependent universes. The idea of observer-dependent universes suggests that reality isn't fixed or universal, but instead depends on the person observing it. In this view, each observer experiences their own version of the universe, shaped by what they perceive and how they interact with the world around them. This idea comes from quantum mechanics, which shows that the act of observing can change the outcome of an event. At the smallest scales, particles like electrons don't have specific locations or properties until someone observes them. Before observation, they exist in a superposition, meaning they have many potential states at once. When an observer measures them, they choose one state. This idea raises a big question. If reality changes based on observation, does each person experience a unique universe? In physics, an observer doesn't have to be a person. It could be a camera, a detector, or even an interaction with another particle. An observer is anything that causes a quantum system to collapse into a specific state. But when we think about observers on a larger scale, like you or me, it suggests something deeper. Your perspective might create your version of reality. For example, imagine two people looking at a rainbow. One person sees bright, vivid colors, while the other sees faint hues because of poor eyesight. Both experiences are real to the observers, but the reality they perceive is different. Now imagine this on a quantum level, where particles and systems themselves might behave differently depending on who or what is observing them. If observer-dependent universes are real, it means your reality is shaped by how you observe and interact with it. Every decision you make, every measurement you take, and even your unique perspective contribute to the universe you experience. Someone else, standing in the same place but observing differently, might experience a slightly different reality. For instance, a scientist studying a quantum particle sees it behave as a wave in one experiment and as a particle in another. The way the scientist sets up the experiment affects what they observe. Two people watching a sports game may disagree on what happened during a play. Their observations, shaped by their angles, attention, and biases, create different realities for them. While these examples are simple, they reflect a much deeper truth about the role of observation in shaping experience. If each observer experiences their own universe, you might wonder, can these universes overlap? The answer is yes, in a way. When people share the same experiences or agree on what they observe, their realities align. This alignment creates a shared version of reality, like the one we rely on in everyday life. But the fact that we can perceive and interpret things differently suggests that shared reality is not absolute. It's a consensus built from individual observations. In some cases, observers don't agree. This is where things get interesting. In quantum mechanics, experiments show that two observers can measure the same event and get different results depending on how they measure it. This challenges the idea of an objective, universal reality. It suggests that what's real for one person might not be real for another. For example, in a famous thought experiment called Wigner's friend, one observer, the friend, measures a quantum system and sees a specific result. But another observer, Wigner, who hasn't looked at the result yet, might still describe the system as being in superposition. Until Wigner observes the system, their version of reality includes all possibilities, while the friend's reality includes only the one they measured. Both perspectives are valid in their own context. While observer-dependent universes sound abstract, they have some interesting implications for how we think about reality. Personal perception matters. Your perspective shapes the way you see the world, literally and metaphorically. This doesn't just apply to quantum systems. It's true for how you interpret events, relationships, and choices. No single truth, If reality depends on observation, then no single version of the truth exists. This doesn't mean anything goes, but it suggests that different perspectives can all be valid within their own context. Reality is interactive. The way you observe and engage with the world isn't passive. It helps shape what you experience. The biggest challenge with this idea is that it's hard to prove. We can't step outside our own perspective to see if reality looks different to someone else in a truly fundamental way. Experiments in quantum mechanics show that observation affects outcomes, but whether this scales up to larger systems, like people or entire universes, is still unknown. The idea of observer-dependent universes challenges the way we think about reality. If each person, or even each particle, creates their own version of the universe, then what we call reality might be a patchwork of perspectives. These perspectives overlap and align in some ways, but remain deeply personal in others. Whether or not this idea applies to the universe as a whole, it reminds us of something simple but profound. The way we observe the world matters, and it shapes the reality we experience. Fifth-dimensional universes. A fifth-dimensional universe is an idea that goes beyond the three dimensions we experience daily: length, width, and height, and the fourth dimension of time. It suggests the existence of an extra dimension that we cannot see or directly experience. This fifth dimension could hold other universes or provide a way to connect different points in space and time. Let's start with what dimensions are. A dimension is a direction you can move in. In our world, you can move forward or backward. That's one dimension. Left or right, that's another. And up or down, the third dimension. Time is often called the fourth dimension because it moves in one direction, from the past to the future. Now imagine adding a fifth dimension. It's not like anything we know. We can't see it, touch it, or move through it. But scientists and mathematicians think it could exist based on the math that describes the universe. The idea of a fifth dimension comes from attempts to explain some big mysteries in science. For example, gravity. Gravity is weaker than other forces, like electromagnetism. Some scientists think this might be because part of gravity leaks into a fifth dimension. String theory. String theory, which tries to explain how everything in the universe works, says there are more than three dimensions. It predicts the existence of extra dimensions, including the fifth. The multiverse. A fifth dimension could be where other universes exist, separate from ours but connected through this extra dimension. We can't picture a fifth dimension because our brains are wired to think in three dimensions. But we can imagine it in simpler terms. Think about a piece of paper. It's flat and two-dimensional. Now imagine lifting that paper into a three-dimensional world. From the paper's perspective, the third dimension is invisible and hard to understand, but it still exists. In the same way, we might live in a three-dimensional universe that sits inside a five-dimensional space. The fifth dimension could be around us all the time, but we don't notice it because we're stuck in three dimensions, just like the paper is stuck in two. One exciting idea is that the fifth dimension might be where other universes exist. These universes could have different laws of physics or different versions of reality. The fifth dimension might act as a bridge between our universe and others. It could also connect different points in space and time within our own universe. For example, scientists have speculated that black holes might stretch into the fifth dimension. If true, they could act as shortcuts or wormholes linking distant parts of the universe or even different universes. Scientists have looked for clues that a fifth dimension exists. One way is by studying gravity. If gravity behaves differently at very small distances, it might mean it's spreading into a fifth dimension. So far, there's no solid evidence, but experiments are ongoing. Another way to test for a fifth dimension is through particle physics. Some scientists think particles could gain extra energy if they interact with the fifth dimension. This extra energy might show up in high-energy experiments, like those at the Large Hadron Collider. If the fifth dimension exists, it changes how we think about the universe. It suggests our universe is part of something much larger. It also raises questions. Could we ever interact with the fifth dimension? Could it help us travel through space and time? Could it reveal new ways to understand reality? These questions are still unanswered, but they show how the idea of a fifth dimension opens up new possibilities. Fifth-dimensional universes challenge us to think beyond what we can see or touch. They remind us that our understanding of the universe is still growing. Even though we live in 3 dimensions, the universe might be far more complex. The fifth dimension might hold answers to mysteries we haven't even thought to ask yet. The idea of a fifth dimension can feel abstract or even strange, but it's part of serious scientific efforts to understand the universe. Whether it's helping explain gravity, connecting us to other universes, or unlocking new ways to think about space and time, the fifth dimension might be more real than we imagine, just beyond our reach, but waiting to be discovered. Mirror universes. The idea of mirror universes suggests that there might be realities where everything exists in a reversed or opposite form. These universes could have different physical laws, flipped properties, or even events that run backward compared to ours. They are called mirror universes because they act like a reflection, similar to our universe, but not exactly the same. To picture a mirror universe, think about how your reflection in a mirror looks. It resembles you but appears reversed. If you raise your right hand, your reflection raises its left. A mirror universe would work in a similar way. It could be a reality where time flows backward instead of forward. Matter is replaced with antimatter. The universe's fundamental forces, like gravity or magnetism, are reversed. Some scientists use the term mirror universe to explore the possibility of universes where these reversals happen. They wonder if such universes could exist alongside ours, perhaps even influencing it in subtle ways. One version of this idea suggests that a mirror universe might have time running backward. Imagine a reality where the Big Bang is not the beginning but the end, and all events move from future to past. In that universe, someone could unbreak a glass or unspill water, seeing time as completely reversed. To them, our world might seem backward just as theirs would seem to us. Another version of the mirror universe theory involves antimatter. In our universe, matter makes up almost everything: stars, planets, and even us. Antimatter is its opposite. When matter and antimatter meet, they destroy each other. A mirror universe could be made mostly of antimatter, while our universe is made of matter. This might explain why antimatter is so rare in our reality. It could have ended up in its own mirrored world. Mirror universes are hard to detect because they might be completely separate from us. However, some scientists believe that we might see hints of them in our own universe. For example, dark matter. Dark matter is an invisible substance that makes up much of the universe's mass, but scientists don't fully understand it. Some theories suggest dark matter could be regular matter from a mirror universe leaking into ours. The arrow of time. Time in our universe seems to move only forward. A mirror universe with time running backward might explain why time flows the way it does here. If a mirror universe exists, life there could look very different, or very similar. It might have people, animals, and landscapes that resemble ours, but behave in unexpected ways. Or it might have forms of life so alien to us that we wouldn't even recognize them. For example, a person in a mirror universe might age backward, starting old and becoming younger. Planets could orbit in reverse directions, with seasons running opposite to ours. Even physics could work differently, creating strange materials or environments. The concept of mirror universes helps scientists think about symmetry in nature. Symmetry is the idea that certain patterns repeat or balance each other. For example, our universe has particles and forces that obey specific symmetries. A mirror universe might have its own set of symmetries, offering clues about why our universe works the way it does. Some theories, like string theory, predict that mirror universes might naturally arise from the mathematics of how the cosmos is built. Exploring these ideas might help us answer big questions about reality, like why there is more matter than antimatter, or why time flows in one direction. Right now, mirror universes are just a theory. We don't have direct evidence that they exist. Scientists continue to study phenomena like dark matter, particle behavior, and cosmic events to see if they point to a mirrored reality. Advanced experiments, like those at particle colliders, might one day reveal clues about these hidden worlds. The idea of mirror universes challenges us to rethink what reality could be. If these reversed or opposite worlds exist, they might hold answers to some of the universe's deepest mysteries. Whether they are places where time runs backward, antimatter rules, or physics flips, they remind us how much we still have to learn about the cosmos. Somewhere out there, a reflection of our reality might be waiting to be discovered. Dark matter universes. Dark matter is one of the biggest mysteries in science. It's called dark because we can't see it, touch it, or interact with it directly. Yet scientists know it exists because of the way it affects the universe. For example, dark matter's gravity holds galaxies together and influences how stars move. Without it, the universe wouldn't look the way it does today. But what is dark matter, really? One fascinating idea is that dark matter could be a sign of other universes overlapping with ours. These dark matter universes might exist alongside us, invisible but still influencing our universe in subtle ways. Before we dive into the idea of dark matter universes, let's understand dark matter itself. Scientists estimate that about 85% of the matter in the universe is dark matter. Unlike normal matter, it doesn't emit light or energy, so we can't see it with telescopes. We only know it's there because of its gravity. For instance, galaxies spin faster than they should based on the amount of visible matter. Dark matter's gravity explains this. Clusters of galaxies bend light from distant objects, a phenomenon called gravitational lensing. This bending is too strong to be caused by visible matter alone. Despite its importance, scientists still don't know what dark matter is made of. It doesn't interact with normal matter in ways we can easily detect. This makes it one of the biggest puzzles in physics. One idea is that dark matter might not be stuff in our universe at all. Instead, it could be part of another universe that overlaps with ours. Think of it like two sheets of paper stacked together. Each sheet represents a universe. They don't directly touch, but their gravity can still affect each other. In this scenario, dark matter isn't invisible because it's weak or distant. It's invisible because it belongs to a different universe entirely. The particles or objects in that universe might be interacting with ours only through gravity, which is why we can feel its effects but not see or touch it. If dark matter comes from another universe, that universe might be very different from ours. It could have its own set of rules, its own physics, and its own structures. For example, it might have stars and galaxies, but they wouldn't emit light like ours do. Time might flow differently, or not at all. The beings or objects in that universe might not even recognize ours as existing. On the other hand, a dark matter universe could be almost identical to ours, with subtle differences. It's possible that their version of normal matter is what we see as dark matter. To understand overlapping universes, scientists look at theories like Brane Cosmology. This theory says that our universe is like a 3D membrane, or brane, floating in a higher dimensional space. Other branes could exist in this same space, close enough to affect ours but still separate. If a dark matter universe is another brane, its gravitational influence might leak into our universe. This would explain why dark matter behaves like invisible mass, pulling on stars and galaxies without interacting with them in any other way. Testing the idea of dark matter universes is tricky. Since these universes wouldn't interact with ours directly, we can't see them or measure them with traditional tools. However, scientists are exploring gravitational waves, ripples in space-time caused by massive objects. If dark matter universes exist, their gravitational waves might leave faint traces in ours. Anomalies in gravity. If gravity behaves strangely in certain regions of space, it could hint at the influence of another universe. For now, these are just ideas, but they push us to think creatively about what dark matter might be. The idea of dark matter universes helps us think about our place in the cosmos. It suggests that our universe might not be the only one, and that we could be part of something much larger. Even if we can't see or interact with these other universes, their existence could explain many mysteries, like why the universe is structured the way it is. This theory also reminds us how much we don't know. Dark matter is one of the most studied topics in physics, but its true nature remains elusive. The idea of dark matter universes opens up a whole new way of thinking about the problem. Dark matter is a mystery, and so are the possible universes it might represent. whether it's a shadow of another cosmos or something entirely different, it challenges us to think beyond what we can see. If dark matter is a clue to another universe, then the fabric of reality is far stranger and far more connected than we ever imagined. Somewhere out there, in a reality we can't touch, the answers might be waiting. Virtual subuniverses. The idea of virtual subuniverses suggests that our universe might not be the ultimate reality. Instead, it could be one of many layers of nested universes, where each layer exists within another, like Russian dolls. These subuniverses might even be created and controlled by advanced civilizations or systems in the parent universe. This concept starts with a simple question. Could a civilization become advanced enough to simulate an entire universe? If they can, then it's possible that our universe is one of those simulations. In fact, there could be countless simulations, each one a fully functioning reality with its own laws of physics, galaxies, and even intelligent life. To create a subuniverse, you would need a system capable of simulating not just a few objects, but an entire reality. Think of how video games simulate small virtual worlds. Now imagine a computer powerful enough to simulate a universe as vast and complex as ours, with stars, planets, and people. In this scenario, our universe might be like a giant video game running on an unimaginably advanced computer. The players or creators could observe our universe from the outside, but we, as the inhabitants, would never know we're inside a simulation. If this is true, then the universe running our simulation could itself be a simulation. The creators of that universe might also live in a simulated reality, created by yet another higher-level system. This could go on indefinitely, creating a chain of universes nested within one another. Each universe would see itself as real, even though it's just one layer of a much larger structure. For example, the base universe contains a super-advanced civilization. This civilization creates a simulated universe. Beings in the simulated universe eventually create their own simulations. This cycle repeats, forming an endless chain of subuniverses. Some scientists and philosophers think there's a good chance we are in a simulated universe. Their reasoning is simple. If it's possible to create a simulation, then many simulations could exist. In fact, there might be far more simulated universes than real ones. If that's true, the odds are that we live in a simulation rather than the original base reality. If we're in a virtual subuniverse, it changes how we think about reality. Everything we see, touch, and experience might be part of a program. The laws of physics, like gravity or time, could be the rules written into the simulation. It also raises big questions. For example, who created our universe? Was it a person, a machine, or something else? Why did they create it? Are we part of an experiment, a form of entertainment, or something beyond our understanding? Could they shut down the simulation? If they did, would everything we know simply disappear? Right now, we have no way to prove or disprove this idea. If we're in a simulation, it's designed so we can't see beyond it. The limits of our universe, like the speed of light or the edges of space, might be boundaries of the program. Even if we found glitches or strange phenomena, we couldn't be certain they're evidence of a simulation. However, some scientists suggest looking for patterns or rules that seem artificial. For example, if the universe is pixelated at its smallest scale, like a computer screen, it might hint that it's programmed. If the virtual subuniverse idea is correct, it doesn't mean our lives are meaningless. Even if we're in a simulation, our experiences, relationships, and actions still matter. To us, this universe is real, no matter how it came to be. It also opens up exciting possibilities. If we ever become advanced enough, we could create our own simulated universes. In fact, we might already be doing it in a small way with our computers and virtual reality systems. Someday, our simulations could grow so complex that the beings inside them wonder if they are real. The concept of virtual subuniverses challenges us to rethink what reality means. Whether we're in the original universe or a simulated one, the idea reminds us of how little we truly understand about existence. It's a humbling thought, but also an inspiring one. If our universe is a simulation, it's a beautifully complex one, filled with wonders we're only beginning to explore. Thermodynamic Universes. The idea of thermodynamic universes comes from the way energy and matter behave over time. It connects to a concept in physics called entropy, which measures how ordered or disordered a system is. Entropy tends to increase as time passes, which means systems naturally move from order to disorder. This process shapes how the universe evolves and might even explain how new universes could form. Think of entropy as a way to measure randomness. A tidy room has low entropy because everything is in its place. A messy room has high entropy because it's disorganized. The universe works the same way. Early in its life, the universe had low entropy. Matter and energy were tightly packed and organized. Over time, stars, galaxies, and planets formed, and entropy began to increase. Eventually, the universe could reach a state where everything is spread out and disorganized, what physicists call heat death. Heat death doesn't mean the universe will get cold everywhere. Instead, it means energy will become so evenly spread that nothing interesting can happen. Stars will burn out, black holes will evaporate, and no new structures will form. The universe will be in a state of maximum entropy, where everything is uniform and unchanging. The theory of thermodynamic universes suggests that the universe might not stop at heat death. Instead, it could restart in a cycle of destruction and rebirth. Here's how it could happen. Heat death. The universe reaches maximum entropy and becomes a dark, empty space. Quantum fluctuations. Tiny random events at the quantum level might create small pockets of energy or matter. New universe. Over an unimaginably long time, these fluctuations could trigger the formation of a new universe, similar to how the Big Bang began ours. This process is sometimes called the Big Bounce, where the end of one universe gives rise to the next. It's like the universe is recycling itself, using the energy left over from the old one. If thermodynamic universes are real, this means our universe might not be the first. Countless universes could have come before ours, each following the same cycle of birth, evolution, and heat death. Our universe could also be part of an endless series of universes that stretch backward and forward in time. Thermodynamic universes help answer big questions about the fate of everything. Scientists often wonder what will happen to the universe when it runs out of energy to sustain life, stars, and galaxies. The idea of new universes forming from the remains of old ones offers a hopeful possibility. The cosmos might never truly end. Alternate laws of logic. The idea of alternate laws of logic is a thought experiment that challenges how we understand reality. Logic, as we know it, helps us make sense of the world. It relies on rules like cause and effect, consistency, and non-contradiction. These rules seem universal. They apply everywhere, from solving math problems to understanding the physical world. But what if they aren't the only way things can work? What if other realities follow entirely different rules? Laws of logic are the basic principles that guide reasoning. They include the law of non-contradiction. Something can't be true and false at the same time. For example, a light can't be both on and off at once. The law of identity. Something is what it is. A chair is a chair, not a table. The law of excluded middle. A statement is either true or false, with no middle ground. These principles feel so fundamental that we assume they apply everywhere. But the idea of alternate laws of logic asks us to imagine other systems of reasoning where these rules might not hold. In a reality with alternate laws of logic, the rules we take for granted could work differently. For example, a single thing might be able to exist in two contradictory states at once. A door could be both open and closed. Identity might not be fixed. A tree might also be a river, depending on how you look at it. Truth might not be absolute. Instead of being either true or false, something might be partly true, or true in some ways but false in others. These changes would make such a reality very different from the one we know. Events might not have clear causes, objects might not stay consistent over time, and predictions might be impossible. Alternate laws of logic might seem impossible to us, but they could make sense within their own framework. Think of them like the rules of a game. Chess and checkers have different rules, but each game works on its own terms. Similarly, a universe with different logic could operate smoothly according to its own set of rules, even if those rules seem strange to us. One example of alternate logic comes from quantum mechanics. At very small scales, particles behave in ways that seem illogical. For instance, a particle can be in two places at once, a phenomenon called superposition. Two particles can affect each other instantly, even if they're far apart. This is called quantum entanglement. These behaviors don't fit neatly into our everyday understanding of logic. While they don't fully break the rules of classical logic, they hint at how a different system of reasoning might work. The idea of alternate laws of logic forces us to question assumptions about reality. It helps us recognize that the way we think about the world isn't the only way to think. This opens up possibilities for understanding other forms of existence, especially in areas like philosophy. Can we imagine a world where contradictions don't matter or where identity is fluid? Mathematics. Are there systems where standard rules of logic don't apply, yet still produce useful results? Physics. Could other universes operate with completely different structures of cause, effect, and interaction? By considering alternate logic, we expand the way we think about the universe. It challenges us to imagine realities that might be wildly different from our own. So far, we have no evidence of a universe with alternate laws of logic. However, this doesn't mean they couldn't exist. The multiverse theory suggests there could be infinite universes, each with its own rules. Some of these universes might not follow our logic. While we can't observe or test such universes, they're a useful concept for stretching our understanding of what's possible. Even in our own reality, we sometimes encounter situations that feel like they defy logic. Optical illusions can make something appear to be two things at once. Paradoxes, like the statement, "This sentence is false," can't be resolved within normal logic. Human emotions and decisions often don't follow strict rules of cause and effect. These examples don't prove alternate logic exists, but they show that our understanding of logic isn't always perfect or complete. The idea of alternate laws of logic reminds us that our understanding of the world is shaped by the rules we know. If other universes exist with different rules, they might seem impossible or incomprehensible to us. But to the beings in those universes, their rules would feel just as natural as ours. Exploring these possibilities helps us think beyond the limits of our experience. It doesn't mean we abandon the logic we rely on, but it encourages us to imagine a universe where thinking itself might work in ways we've never considered. We live in a universe where logic feels reliable, where causes lead to effects, and where things are either true or false. But in the vastness of the multiverse, could there be places where none of this holds? Could there be a reality where thinking itself follows rules we can't imagine? The idea of alternate laws of logic may be unprovable, but it reminds us of the boundless possibilities of existence. Multiverse within your mind. The idea of a multiverse within your mind is a thought-provoking concept that combines science and imagination. It suggests that your mind might create its own versions of reality. These mental realities, while not physical, could still have meaning and influence how you experience the world. This concept ties into the way our brains work. Your mind constantly processes information, makes decisions, and imagines possibilities. When you think about what-if scenarios, like what would happen if you took a different job or moved to a new city, you are, in a way, creating alternate versions of your life. These imagined realities don't exist in the physical world, but they are real in your thoughts. Your imagination is a powerful tool. It lets you picture things that haven't happened or may never happen. For example, you can imagine a world where gravity doesn't exist or where people can fly. When you do this, you're creating a kind of mental multiverse. Each imagined scenario is like a separate universe within your mind. Unlike the many worlds interpretation of quantum mechanics, where all possibilities exist physically in separate universes, the multiverse within your mind exists only in your thoughts. However, the process of imagining these alternate realities could still shape your decisions, emotions, and creativity in your daily life. Dreams are another way your mind might explore its own multiverse. When you dream, your brain generates vivid experiences that often feel real while they're happening. You might find yourself in a world with different rules, meeting people you've never known, or living a completely different life. These dream universes are created entirely by your mind, but they can feel as immersive as waking reality. Some scientists believe that dreams might reflect your brain's way of processing emotions, solving problems, or experimenting with possibilities. In this sense, dreams could be a window into the multiverse within your mind, a space where your brain explores scenarios it can't test in the real world. Every choice you make begins as a thought. Before deciding, your mind considers multiple options and their possible outcomes. For instance, you might weigh the pros and cons of taking a new job or staying in your current one. In your mind, you imagine both possibilities, each with its own universe of experiences. Once you choose, the other possibilities fade, but they don't completely disappear. They remain as memories of what could have been, shaping how you view the choice you made. This process shows how your mind is constantly creating and collapsing its own versions of reality. The multiverse within your mind plays a huge role in creativity. Artists, writers, and inventors often imagine alternate worlds, new ideas, or novel solutions to problems. These imagined realities can lead to groundbreaking innovations or works of art. For example, a writer might imagine a fictional world with its own rules and characters. A scientist might picture how a theory works in a completely different context. A problem solver might imagine different approaches to a challenge. The ability to explore these mental multiverses allows us to think beyond the limits of the physical world. The universes within your mind aren't real in the way physical objects or events are real. You can't touch or measure them. However, they can have real effects on your life. Your thoughts shape how you understand the world, how you solve problems, and how you interact with others. In this sense, the mental multiverse is real because it influences your decisions, feelings, and actions. This concept also ties to some philosophical and scientific questions. For instance, if consciousness creates its own version of reality, how much of what we experience is shaped by our minds? Do other people have their own mental universes that are just as rich and complex as ours? And could these imagined worlds ever overlap in meaningful ways? The multiverse within your mind is a reminder of how powerful and creative human thought can be. Whether you're imagining a better future, dreaming about fantastical worlds, or replaying past decisions, your mind is constantly exploring possibilities. These mental universes might not exist physically, but they are deeply personal and uniquely yours. By understanding and exploring them, you can better appreciate how your mind shapes the way you see and experience the world. Absolute zero universes. An absolute zero universe is a theoretical concept where the universe has cooled to the lowest temperature possible, absolute zero. At this temperature, there is no heat, no motion, and no energy left to power change. Everything is frozen, not just physically, but also in terms of time and events. To understand this idea, let's first talk about absolute zero. In science, absolute zero is the coldest temperature imaginable. 9-270.15 degrees Celsius, or 0 Kelvin. At this point, atoms stop moving entirely. In our universe, absolute zero is impossible to reach because even the smallest amount of energy keeps atoms vibrating. But if a universe somehow cooled to absolute zero, it would be stuck in a timeless, unchanging state. In an absolute zero universe, nothing happens. There is no heat to drive chemical reactions, no energy to power stars or life, and no motion at all. Matter would exist in a completely frozen state, with atoms locked in place. Light, which depends on energy, wouldn't exist either. It would be total darkness, with no time or events to measure. This kind of universe would feel like hitting the pause button forever. Since there's no energy to cause change, it would remain the same for eternity. One way this could happen is through the heat death of the universe. Scientists believe that our universe is slowly using up its energy. Over billions of years, stars will burn out, black holes will evaporate, and the universe will expand until all matter is spread thin. At that point, no energy will remain to create heat or motion. While this scenario doesn't technically reach absolute zero, it comes close. In theory, an absolute zero universe could form if this cooling process went even further. If every last bit of energy somehow disappeared, the universe would freeze completely. Time depends on change. We measure time by observing events, like the ticking of a clock or the movement of a planet. But in an absolute zero universe, there would be no movement or events. Without change, time would have no meaning. the universe would exist in a kind of eternal stillness. Life as we know it depends on energy. We need heat from the sun, chemical reactions in our bodies, and energy to fuel our cells. In an absolute zero universe, none of these things could happen. Without energy, life would be impossible. Even the simplest forms of existence, like particles interacting, wouldn't occur. Yes, for now, it's purely theoretical. Scientists don't believe our universe will ever reach true absolute zero. There's always a tiny amount of energy in the form of quantum fluctuations, even in the emptiest space. These fluctuations prevent the universe from freezing completely. However, thinking about absolute zero universes helps scientists explore the limits of physics. It raises questions about energy, time, and the nature of existence itself. What happens when all energy is gone? Can time exist without events? These are big questions, and absolute zero universes give us a way to think about them. Absolute zero universes remind us how much we rely on energy and motion to make life possible. Without them, the universe would be a silent, dark, and frozen place. While this might seem bleak, it also shows how special and dynamic our universe is right now. The heat and energy we take for granted are what make stars shine, planets orbit, and life thrive. An absolute zero universe may never exist, but imagining one helps us appreciate the forces that keep our universe alive. Energy drives change, and change gives us time, motion, and the chance to experience the world. In the stillness of absolute zero, none of that would exist. It's a humbling reminder of how delicate and temporary our universe's energy truly is. Photonic Multiverse. The Photonic Multiverse is a fascinating idea that imagines a universe made entirely of light. In this type of universe, there would be no matter, no gravity, and no physical objects as we know them. Instead, everything would consist of photons, the tiny particles of light that carry energy and information. This concept comes from the observation that photons behave very differently from other particles. Unlike objects with mass, photons don't need a resting place. They move at the speed of light, which means they experience no time. To a photon, the journey from one point to another is instantaneous, no matter how far it travels. This unique quality makes photons very different from the particles that make up ordinary matter, like electrons or protons. In a photonic universe, there wouldn't be stars, planets, or living creatures like us. Instead, the universe would be a sea of light waves, constantly moving and interacting. These waves could overlap, creating patterns and structures that we can't easily imagine because they wouldn't follow the same rules of space and time we're used to. This kind of universe might still have beauty and complexity. The way light waves combine and interact could create intricate patterns, like a cosmic dance of energy. In such a universe, the concept of space might exist only as a medium for light to move through. There might be no gravity to pull things together, and no mass to slow anything down. In our universe, light plays an essential role. It helps us see, powers life through photosynthesis, and carries information across the vast distances of space. But light isn't the only thing here. Our universe also has matter, gravity, and the forces that hold particles together. The idea of a photonic multiverse suggests that other universes could exist where light is the only thing present. These universes might operate under completely different physical laws. For example, time might not exist in the same way because photons don't experience time. Space could behave differently because there's no mass to define distances or create forces like gravity. If a photonic universe exists, it would be almost impossible for us to interact with it. Matter and light behave very differently, and a universe made of light might be invisible to us in every sense. However, some scientists think that clues about such universes could show up in the behavior of light in our own universe. For example, experiments in quantum mechanics show that light can behave in strange ways, like existing in two places at once or passing through walls. Some physicists wonder if these behaviors could hint at connections to other kinds of universes, including photonic ones. The idea of life in a photonic universe is hard to imagine because life as we know it depends on matter. Living things are made of atoms, and atoms rely on forces like gravity and electromagnetism to stay together. But in a photonic universe, there might be no atoms at all. Still, some thinkers speculate that patterns of light could serve as a kind of consciousness. These patterns might not think or feel in the way we do, but they could represent something like awareness. It's a speculative idea, but it shows how even a universe made of nothing but light could hold surprises. The Photonic Multiverse helps us think about what's possible in the vast expanse of reality. It reminds us that our universe, with its matter, gravity, and time, might not be the only way the cosmos can work. Other universes might exist with entirely different rules, and understanding them could help us understand our own universe better. It also raises questions about the nature of light itself. Light is a fundamental part of our universe, but it's also mysterious. It behaves both like a wave and a particle, and it doesn't seem to age the way other things do. Exploring the idea of a photonic universe forces us to think more deeply about what light really is and how it shapes the world around us. The Photonic Multiverse invites us to imagine a reality where light is everything. There's no matter, no gravity, and no time as we know it, just endless waves of light moving and interacting. While this idea may seem far removed from our everyday experience, it challenges us to think beyond the limits of our world. In doing so, it reminds us that the universe, or perhaps the multiverse, is more vast and varied than we can ever fully understand. Dimensional leak universes. The idea of dimensional leak universes suggests that our universe might not be completely separate from others. Instead, there could be times when something from another dimension or universe leaks into ours. These leaks could cause strange events that don't fit with what we understand about the world. Imagine our universe as a flat sheet of paper. Now imagine another universe as a different sheet stacked nearby. Normally, these sheets don't touch or interact. However, if one sheet bends or warps, it might briefly overlap with the other. When this happens, some parts of one universe could cross into the other. This overlap is what we call a dimensional leak. These leaks don't have to be physical objects moving between universes. They could also be energy, information, or even subtle changes in how things work in our universe. Dimensional leaks could explain unusual phenomena that science struggles to explain. For example, the Mandela effect. This is when large groups of people remember something differently from how it is. Some believe it's caused by small shifts between universes. Unexplained objects or beings. Reports of mysterious objects, strange creatures, or unexplained lights could be signs of something leaking from another dimension. Déjà vu. The feeling that you've experienced something before might be a glimpse into a parallel universe. While these events are often dismissed as tricks of memory or imagination, dimensional leaks offer another possible explanation. There are a few ways scientists think leaks might occur. Weak boundaries between universes. If the walls between dimensions are thin in some places, things might pass through. High energy events. Extreme conditions, like black holes or powerful explosions, might create temporary connections between dimensions. Quantum fluctuations. On the smallest scales, particles behave unpredictably. These quantum effects might briefly bridge universes. If leaks are possible, you might wonder why they aren't happening all the time. One reason could be that leaks are rare and unpredictable. The conditions needed to create them might only happen in specific places or at certain times. Another possibility is that most leaks are too small or subtle for us to notice. It's also possible that leaks don't last long. If a connection between universes opens and closes quickly, we might only catch brief glimpses of the effects. If dimensional leaks are real, they could reshape how we think about reality. It would mean our universe isn't isolated, but part of a larger system of connected dimensions. These connections might explain some of the mysteries of the universe, like where dark matter comes from, why we experience time in one direction, how the laws of physics could vary in different parts of reality. Leaks could also mean there are ways for information, or even life, to cross between dimensions. While this might sound like science fiction, it opens up possibilities for exploring the multiverse in ways we've never imagined. So far, dimensional leaks are just a theory. Scientists haven't found direct evidence of them, but they're looking. For example, particle accelerators. Experiments like those at CERN might detect particles that don't fit with our universe, suggesting they came from another. Quantum experiments. Researchers study particles to see if their behavior hints at influences from other dimensions. Astrophysics. Observations of space might reveal events like bursts of energy that could point to a leak. Proving dimensional leaks would be challenging because they involve realities beyond what we can directly observe. Still, the idea encourages scientists to keep asking questions about how our universe connects to others. The concept of dimensional leaks matters because it could explain things we can't currently understand. It also challenges the idea that our universe is a closed system. If leaks exist, they suggest that other dimensions aren't just theoretical. They might actively influence our reality in small but meaningful ways. Dimensional leak universes remind us that our understanding of the cosmos is still incomplete. If there are times when the boundaries between dimensions blur, then the universe is even more complex and interconnected than we thought. The next time you experience something strange or unexplained, consider this. It might just be a whisper from another dimension, slipping briefly into ours.